Hello? Is that good now? I forgot to turn on my microphone. Are we good? Still no sound? Yes, we're good? Okay. All right. Well, how's everyone doing? So anyway, I was saying welcome to another What Will You Make Me Fix Wednesday. Another week has went by and what? Much better. Okay, cool. so, um, so I have a few different machines that are in the list here, and they're all eBay finds apparently. People sent three. I had multiple people send me stuff off of eBay all at the same time, and then I also have one that's off of Facebook Marketplace. But I put all the eBay ones together, so pretty interesting. So all three of them there, I put them listed. So like one's a no power, one's a no post, and one like had like a BIOS password or something. They tried to flash it, and it didn't. Now it's giving like an orange light of death or something like that. Daryl Flores just donated $5 to the stream. Thank you so much, Daryl. I can always count on you for that. Looks like my title on the bottom of the screen is still dodgy CPU repair, or raw dogging the CPU repair, dodgy style. That was last Sunday, so if you missed it, last Sunday I tried to install or tried to transplant a CPU, and of course it was going to fail because I had inadequate equipment, and that was what the plan, we were going to just see what we can do, so. But hello everybody, hello everybody. So all the eBay finds are going to be pretty interesting, I think. The 9520 is going to be, how do you say your name? Luca? Is that what it is? Luca Cell? So they're in chat there, so that's good. We got one person in chat. I don't know who else is here. I did a new layout on the screen here. You can see the chat on the screen's a little different. Let me know if you like that better or not. I don't know. I'm just kind of playing around with trying to make it a little cleaner for the chat. The main issue I'm having is just trying to keep up with the chat, and I know that I've been doing very poorly with this, and I've been told. And I'm trying to do the best I can. Multitasking is very hard. But hopefully you like the new stream chat. Hopefully that looks a little bit better. Sunday, you watched the crash and burn. And the crash and burn was predicted. I predicted this. This was like, I said it was going to happen ahead of time, most likely. I didn't give myself a high likelihood of success. But Anyway, so y'all vote on that. We have about 10 minutes to vote, and I have a couple things I want to show you guys. But I guess you guys can say hello from wherever you're at. I got hello from Oklahoma, and I got Syracuse, New York. And let's see, yeah, the cool wallpaper. So I made this overlay myself. That's basically behind the chat is like a picture of a circuit board. I just kind of took it at an angle with a light on it, and then I just kind of photoshopped kind of a border around there. So it kind of gives it a nice clean look. So I have it now where we have all the different views together, and I went back to my old thermal camera since you guys were requesting that. And one other thing, I have it where we can do multi-views with the thermal camera in the same view, which was nice, so we can have it at the same time. So a few different things I kind of modified. I know that we were working on different things. So we got Idaho. Oh no, I forgot to pay attention. You saved your laptop today. I saved your laptop today? Did I really? Saved another laptop. Oh, right. So Shane just donated $10, and I just worked on Shane's laptop today, talked to him for a long time, and I fixed his laptop up. That was a fun one. He had some, the LCD connector needed to be replaced, and then we also had to fish the cables and try to fix the infrared camera. So, all right, let me get back over here to where everyone is at. We got the UK, I got Netherlands, I have Arizona, Mesa, Arizona, North Carolina, and Arizona again, and New York, Dubai, and we have Northwest, the UK, Texas, Colorado, Pennsylvania, North Carolina, Wisconsin, Germany, Princeton, Texas, Wichita, Kansas, Paris, Paris, Canada, Argentina, and who else is from North Carolina? You got a shout out. So Italy, yes, cast your votes. I want to pull up the polls here. Let's see if the polls are going to show up properly. They are a little bit. Here, let me see if I can fix this. Let's see. There we go. We can kind of see it. Yeah, it's not showing all three of them on this YouTube one. I don't know. It's hard for me to do that, but we can see that the Alienware is winning right now on both. So could be interesting. Okay, back to the locations here. I'm trying to do my best I can reading at the same time. I'm sorry. We got Oregon, Scotland, Greece, Connecticut, Alabama, Virginia, New York, North Carolina. Let's see, Italy, Argentina. Yes, and Montgomery. So I did get a package from Montgomery White, and I'm going to show you what he sent me. It was an early Christmas present, and he sent me this cigar holder, and it's packed with some cigars. He knows how much I like cigars. So these are nice Gentleman Jack cigars. Check this out. It's pretty slick. So 3 of those guys. And some coffee, because he knows how much coffee, how much I love coffee. Buckeye blend. And the last thing he got, they sent in. This is pretty cool. Check this out, guys. Check this out. Look at that. Isn't that pretty slick? It's a water bottle that has an alien head on it. So thank you so much, Montgomery. Appreciate that. That is awesome. That was very nice of you to do. Back to the locations. Sorry, you guys are just dumping this stuff out here. We have, I changed my chat up, and now it's actually making it too hard for me to read because it moves even faster than before. So give me a second. Let me see if I can fix this because it's a little bit too fast for my eyes, my old eyes. Let me see if I can change this back. There we go. Let's see if that's better. I was editing some CSS to make it better. All right, Michigan, Virginia, and it's hard for me to keep up with that. Okay, with all the locations. But anyway, hello from all around the world. We got 360 people on the YouTube and 37 on Twitch. We're going to be working on, we have 3 different machines inside the queue. Make your votes. I don't know, I haven't looked at any of these. The only one, I did show you a preview of one of them on Sunday, and it was a spray painted one. So that 5411 is actually one that's been spray painted. It looks like the poll has ended on Twitch, and 75% goes to the Alienware, and then 48% goes to the Alienware. So we're doing Alienware first, and then it looks like the Latitude 5411 is next. So I'm sorry, the 9520, he's in chat. Don't you guys want that? You usually like to be able to talk to the person in chat. So we'll see if we can get to all 3 of them tonight. The night is young, and hopefully we'll be able to do it. So, and I'll do my best trying to. I also got a cigar cutter. I did not see that. I'll have to see. Monty's saying there's a cigar cutter in here. I did not see a cigar cutter in here. Let me see. Is it in here? I do not see a cigar cutter in here. But I have a cigar cutter at home. Yeah, I don't see one in here. But thank you so much. Thank you so much. The Alienware is the winner. That's what we're going to be working on tonight. First off. And let me see if I can grab it. And I'm not going to do a switcheroo this week. So if you were here last week, I went and grabbed the laptop and then had my brother sit down, my twin brother. Tricked you guys a little bit. Let me end this poll. Three streams in a row for you. Good job. Welcome, welcome. All right, so here's the Alienware in question. Let's pull up his notes to take a look at it, make sure there's no personal information. All right, so you guys love to read the notes, so I'm not going to read. You guys know I don't read very well. So bought off eBay, came with no battery or memory. Bought some memory and installed it. Nothing happens when you press the power button. and it seemed to be taken apart. And something about a 12 volt adapter. These things should be running on 20 volts, so I don't know about that. And a missing drive. And anyway, we'll figure it out. We have all these parts, so not a big deal, not a big deal. Should we get started, or you guys want to chat for a little bit? We can do a little just chatting for a little bit if you'd like, so that way I can try to catch up. Sometimes you guys want to ask questions. Oh, and the 5411, the Latitude 5411's in the chat also. So, is this Alienware in the chat? Did I miss that? Okay. Yeah, let's just get started. We'll do a just chatting at the end like I normally do. Usually spend the last 30 minutes chatting, but let's get started. We'll do the intro. What model is this? M15R5. All right, new day and another laptop that needs to be saved, and this time we have an Alienware M15R5. This is the Ryzen edition. This laptop's an interesting one because it was purchased off of eBay, and it was they purchased it, and it was in non-working condition. It was actually missing a bunch of components. I haven't taken a look at this yet. Let's take a look together and see if we can get this figured out. So that wasn't the best intro, but let's play around with it here. Well, I assume that's not going to turn on. Let's just try to turn it on. And it is not doing anything. So let me press the power. All right, so pay attention to the power meter. We just want to see how much current it draws when we plug it in. And 0. It did nada. Let me try it again. We're going to unplug it, plug it back in. Nothing. So we should have seen something, some sort of jump up, some sort of like, you know, pulling of some current or something like that. So are you all saying there's the cigar cutters in the case? In the case? Okay, well, I'll take a look at that in a little while. I appreciate that. Okay, so if it's not doing anything there when we plug it in, when I press the power button, I'm assuming nothing's going to happen. So this thing is completely dead, completely dead. So, all right, the end, it's done. It doesn't work. What do? We got to open it up, of course. So let's open it up and take a look inside. And the screws are already undone. Well, that's perfect. Makes it a lot easier for me. All right, so the bottom is off. Let's take a quick look around. There's no battery here, like they said. There's a stick of memory. There's no NVMe populated here. We've got the Wi-Fi card, couple of fans, and not much else. So let me get this rear cover taken off. The screws are in there. What if there's no battery? The machine will run with no battery on this, so that's not a big deal. But what we want to do is we're going to want to plug a battery in and see if it powers off the battery, because there's a possibility that the machine will still power on battery only, but not off the charger. So that's what we'll take a look at next. DC adapter is plugged in. Charger's plugged in. And once I get all this off, then we'll see better. Okay. All right, the bottom's off. Let me give you a little zoomy zoom. Okay, so the first thing we usually want to do, we need to figure out like how far the current's going to go on the board. We can plug in the charger here. We can start measuring over here. I can grab a test battery. We can plug it in right there. We can just kind of bypass that. So, and then we'll test to see if the charge circuit's working after that anyway. But let me just grab a test battery. I think that might be quick and easy. Just 2 seconds. Give me a moment. Uno momento. And that's a 15R5. So I got to get a 15R5 battery. This is an R4. I try to label them the best I can. I have stacks of batteries over here for every single type of laptop. There's an old one. You can tell I don't pre-plan this because I don't know what I'm going to need or not. I think this is one. Nope, that's not one. Well, I know I have one here. Just give me a moment. Sorry. I think this is it. No, that's not it. I know which battery it is, but I need the cable to be on it because there's no battery in there. That's the issue. So this should be it. 15R5, R7. Here we go. Okay, I found one. So the issue is, like, I have plenty of these batteries that are this part number, but the cables need to be attached to it already in order for it to fit in here. So I need to find one that had the battery cable already attached, and this one I wrote the model on it. So let's plug it in. Okay, I don't know what I missed in the chat. Sorry about that. Right, battery's plugged in. I don't know how much of a charge is on this, but we will see if it does even power on. We got, okay, she's dead, Jim, she's dead. We'll plug in the charger again, power meter, nothing. I mean, we're getting nothing. So what does that mean? What does that mean, people? A couple different things. I could suspect that there's a short on the board. So that could actually cause that. But let's go ahead and measure our input MOSFETs. We're going to plug in the charger. We're going to measure right here and see if what type of voltage we're getting here. Let's get under the microscope. All right. And I've been having issues with my light. My ring light here on the bottom of my microscope is actually going out. This is my third one of these I've had to replace because I use them so often. And so I just ordered a couple more. What is this going on here? See something. This just may be a byproduct of measuring, but I don't know if you can see that. Let me polarize this a little bit. Is it going to polarize? Don't know why it's not polarizing. Okay, so do you see what I'm trying to show you? If it can get in focus, there's some scratch marks there on the MOSFETs. Now, that's probably just because the customer was measuring there, but I don't know. It's a symptom, or it's a sign. It could be an EC, but on these, they're a little bit different than the EC issues. Is my voltmeter working? It is. Okay, so we are going to measure and make sure we have voltage coming out of the charger. We have 20 volts. Then it's going to come out of these inductors. Okay, and then it's going to go into these MOSFETs and it should come out of these MOSFETs. And they're not coming out of these MOSFETs, and so therefore we're not going to have anything on the output there, but we do actually have something there. Let me zoom out just a little bit for you. So these two are in parallel, these are in parallel, and so these are the protection MOSFETs. These are the first MOSFETs, or the first line of defense for the motherboard. So these are programmed to shut off if it detects a short in this area. Now if I measure on the output here, which goes into this current sense resistor, we're measuring 2.5 volts. Now why are there 2.5 volts there? It means that there's probably not a short on that power rail, because you would have 0 there if it actually was shorted. But if we come over here, actually what I'm going to do is I'm going to unplug the charger. I want to see, I'm going to put it in ohms mode, and let's see if we do have some sort of short in this area, but it doesn't look like we would. Hey, we do. Something, although it's 0, and we don't. See how I just kept holding it there and kept holding it there, and it finally stopped beeping? What's happening there is that when we put it in continuity mode, it's actually injecting a small voltage into the board, and it takes a little bit of time to fill up the capacitors on that rail, and so that's why it gave us kind of a false positive, like there was a short there. So there's no actual short on that part of the power rail. And then what about this one? No short there, no short there. And then this is going to be the charge area. So here's the power management chip. This is what's in charge. This is what's responsible for charging the battery, and also running these MOSFETs, opening and closing those, and also these are the charge MOSFETs for the battery, and that's the charge coil. And so we could have an issue here, but usually the machine will run off a battery. So let me plug the battery back in. I want to see what voltage we're getting on the battery connector. Should I do the smell test? Is that what you want? You want me to do some sniffing? That might be a good idea. Let's see. No, it just smells like someone's house. So, I think it's fine. I didn't check for any bugs, though. There is a bug, though, because it doesn't turn on. That's an issue. It's a bug issue. I'm going to measure the voltage on the battery, too. So we're getting no voltage on the battery. Now, does that mean my battery's dead? I don't know. I don't think it is. It should be charged. But what will happen a lot of times is when you plug a battery into a motherboard that has a short somewhere, it will shut the battery off, or it will tell the battery to shut off, and so it will appear like it's dead. So I think we need to measure around some more. I'm kind of leaning towards us having a short on the motherboard somewhere still. Just somewhere. It doesn't have to be on the main power rail, but just somewhere. So let's get some of these little covers off. We're probably going to have to pull the board because you can't really poke very much stuff on this side. We pull out the Wi-Fi card. This does smell like cats. This does not smell like cats, at least. Bed bugs would be a surprise as F. And that, I mean, I've had it before, but I don't think I'll have it ever again, because that laptop was really messed up looking when I got it. I'm going to go ahead and just pull this board out. It doesn't take that long. Battery play. Yeah, because we could do the soaring thing, put the battery there, and like, let's push some current into the battery. Try to wake up the battery. We could try jumping these MOSFETs. We could try seeing if those MOSFETs are bad. We can try a bunch of different things. Actually, yeah, let's measure these input MOSFETs, but I don't think the input MOSFETs are damaged. Wait a minute. Wait a minute. I just can't see what I'm measuring. So the way I test these MOSFETs is, so we have three, let's see. This one's set up where you have 4 lines in, 3 coming out, and then you have the gate pin that turns it on and off. So I just want to measure the input to the output. That's not shorted. And I want to measure these together, and I want to measure those together. So that's fine. And then this one has the same thing. This time it's 3 on that side and 4 on this side. So this is fine, and that's fine. So there's no, these MOSFETs are fine. There's no issues with that. And all the rest of the circuitry is on the other side of the board, so we have to take it out anyway. The fun part of watching things live is watching me unscrew things. That's so much fun. Poke and hope. Yeah. Or hopefully I can figure it out without having to do too much poking, but just taking clues. Wes made it. Welcome. Oh man. You didn't see the stream from the beginning. What laptop are we voting on? So these are all eBay laptops. So apparently everyone kind of pulled together and said, hey, let's send Nathan a bunch of laptops we bought on eBay. So there's 3 different laptops that came in the last week that were purchased off of eBay from different people. And so there are 3 different models, and this one's an Alienware. The next one we're going to do is the Latitude 5411, and then the one after that is a XPS 9520. All right, and the motherboard is out. All right, this board is so much fun. I love this board. Not really. This isn't the worst board, but these AMD boards have always been my nemesis, just because there's a lot of failures with them. But I'm just going to take the heatsink off too, so we can access everything. But these Ryzen CPUs just have a lot of issues. Hey, the fan just spun on its own. Oh my goodness. Yeah, these are basically dumpster laptops. I don't know how much they pay for them though. Like this one was a pretty good deal. I mean, if they got it, you know, 150 bucks, that might be worth it. $200. Any liquid metal? Not on this one, I don't think, but we'll see. I'll give you all a close-up of the crusties. Here we go. Come on, dude. Okay, here we go. Looks like fairly new thermal paste. It's kind of white thermal paste. I don't know what kind that is. You know what my fear is? Sometimes I just was thinking about this, is that I've had people send laptops in, and then the motherboard, I couldn't fix it or anything like that, and they didn't want to replace the motherboard, so they were just like, yeah, we'll just reassemble it and we'll sell it on eBay as a bad laptop. At some point, someone's going to sell somebody a laptop and they're going to sell it or send it back into me, and I'm like, no, I've already worked on that laptop. But okay, let me get the DC jack too. The GPU is tiny. This is the GPU, that's the CPU. The CPU is tiny, but it is probably a Ryzen 7, I bet. Here, if we can take a gander. Ryzen 7, and I don't know which version. Does it tell me? It's a 2020. And then this is the G20 E5A1. Was that like a 2070 or a 3070? I can't remember. GN20 E5A1. You got a Lenovo for pretty cheap. I don't know what it takes to fix a Lenovo. Never worked on a Lenovo. I hear it's hard to take chips off the board because they're glued on there. I'm sure you said it's 100. So 100 times, but what is the best thermal paste? That people's opinion. Please, thanks for the thoughts. So what we usually use, or we recommend, is going to be the PTM 7950 by Honeywell. So this is a phase changing pad. It's a pad that goes on there, and then when it gets hot, it starts to melt, and then that actually keeps it pretty much the coolest. So thanks for that $10 donation, Black. Hey, we got TKO, coolest fan member now. Welcome aboard. Welcome aboard. All right, so that's plugged in. Let's get another thermal. Well, we're not gonna see, the thermal camera's not gonna do anything, but look at this. Now we're getting 0.01 for a second. Did you see that? Look at the power meter again. So we didn't get this before when we had it installed. What does that mean? What does that mean? Let me get on the thermal camera. I just want to see if we have anything happening, but most likely we're not going to get anything because we're not pulling any current. So we're back to my old thermal camera. The problem with this one has a lot of reflections. That's the only thing I don't like about it, but you can see the board. It focuses pretty good. See how that looks like it's getting hot there, but that's a reflection. So we just kind of have to move around. But you can actually make the outline of the board out. That's what I like about it. So I'm not seeing anything that is heating up at all. I'm going to unplug the charger and plug it back in just momentarily. And I don't see anything either. Let me flip it over. Let's see, ready? Here we go. I don't see anything. Yeah, I just returned the other thermal camera right before the stream. I ran up at the Whole Foods and dropped it off for Amazon return. With a couple days to spare. I kept it for longer than I should have. But the other one, I just could not get my focus right. So I want to get a charged battery for this. This would be so much better if I had a charged battery. Let me grab it. I'm going to grab a donor board. I just want to plug this battery into a donor board and see if it actually detects some charge on it. Because we need to find what's shorted on there if there's something shorted, but I want to figure out if there's voltage on that battery also. Here we go. This board should work-ish. Nope, there's no power management chip on there. Stacks of these boards. They're dying left and right. Okay, this one, battery charging issues, but should work. Yep, okay. Let me plug it in. I just want to, what I'm going to do is plug the battery in and just measure at the jack to see if we have any voltage there. We don't have any voltage there. Let's see if we can charge the battery up a little bit. Wake this battery up. We need to make sure we're working with good stuff. We can't just say, okay, the board's dead, because if I can get that battery to turn on the board, then we know that we have something else going on, not like a catastrophic failure with the board. So, okay, this board. Just want to see if this is just a test board, so I just want to see if it starts charging the battery. Even though it has a note saying it has charging issues. I'm pretty sure this one doesn't charge in Windows or some weird thing like that. Okay, battery's on. We got 12 volts on the charger. I mean on the battery now. So if I unplug it, the battery's turned on. So it's at 10.7, so it's kind of a low voltage battery. Visual inspection, that might be a good idea to do visual inspection. You guys are so smart. Did I check the DC jack? I did not, but here, yeah, I'm using their DC jack. I have a whole bag of them here, so we can just use one of my DC jacks. That might be good. This one takes my bag of jacks. These bag of jacks is a good little mix. I probably should label them, but I just kind of look at it and go, this goes to that, and that goes to that. Here we go. So this is kind of the same style. That's not the right one. Visual inspection. I know. We're going to do a visual inspection right now. I'll let this battery charge for a little bit while we're doing visual inspection. How's that? So we'll just set this off to the side. Since somebody's been in here, right? Makes a lot of sense. You guys are geniuses. All right, top part of the board. Here's where the DC jack plugs in. We did already see that there was some sort of evidence of measurements on here. But we're going to look for any burnt components, any cracked components, anything that are knocked off the board. There's our power management chip. That's our battery plug there. Oh my gosh, this... Here, let me take this daughter board off. It keeps getting in my way. It's like coming unplugged. Okay. All right. That's where the battery plugs in. Let's look underneath here. Look for spills, things like that. I don't see anything there. This one's an interesting model. See, it has a keyboard connector here, keyboard backlight, but it doesn't even use that. It uses this, and it goes to like a MCU board that handles all of that. And then this is like an Alienware board also. That's, well, it is an Alienware, I guess. But they have different Tron options or different light options, so a lot of this stuff isn't even populated. There's a Tron light there. But this board actually goes into a G series also. It's the same board as a G series. Tell me to slow down if I need to. It's LCD connector. We can check some fuses. I mean, there's no, the machine's not turning on, but I guess we can check fuses while we're driving by. Fuses are fine. It's looking good. Looking good. So I don't see anything ripped off. You see, like, you know, there's things that are missing there, but if you look really closely at them, you can see that they have a hump in the solder, which means that, well, I don't know if you can see if there's a hump or not. I don't know. But anyway, you have to trust me. There's a hump in the solder, and that means that there's nothing there. There wasn't anything there. You would usually see the solder was flat. So we'll look around some more. I'll zoom back out a little bit. The EC chip. This machine's a little different with that, but you know, technically it does have an EC chip that can be programmed, but I've never seen it have an issue with the EC chip on these, so not to say it's not the issue, but it's more likely going to be the power management chip. If Dell uses the same board on multiple machines, different ranges, how do they differentiate the products? They keep an alien head on here, I can tell you that. It's like, so Dell has a G series, which is a gaming laptop that uses Alienware parts, but it has plastic and it's cheaper. So you can actually buy like a G series for under $1,000 that has the same specs as a $2,000 Alienware. But a lot of it is like it's a lower end usually. So this is the, or the G series has a lower end, and then it has the higher end version of the same one that is the Alienware version. I don't know. How do they differentiate it? They don't. We differentiate it, but we kind of know. And then I go by the board print number and sort them like that. So this is the K453. They have a K452, K454, and a K456. And each one of those is going to be like the G Series 5510, 5511, 5515, and that's also the Alienware M15R5, M15R6, and M15R7. And then they have the Ryzen edition, they have the non-Ryzen edition. So those are all different versions. There's the BIOS right there. All right, so one thing I'm noticing here, and we're going to zoom back out. This just fell off. Okay. So I don't know if that means anything, but we're going to take note of it because that should be really stuck on there. So here's our GPU, and that's what the little cover was not on, or was falling off. I see some sort of measuring mark right there. This glue looks really discolored here. I don't know if they like tried to recook the GPU or something, because that should not be that color, I don't think. I mean, you agree? I mean, it looks weird to me. Here, oh yeah, we can use this board right here for example. So here's this other board. And that's what color it should be. It should be like clear. But it's this one, it's like orange, like it's been cooked. And it's really hard. It's almost like it's been, it's almost like it's different stuff. Check the fuses. I already checked some fuses, but there's not that many fuses on Dell machines, so I don't know where else to check. But this is something to note, that the GPU might have something to do with something. This is not an easy burrito, I can tell you that so far. This is, I think, the VRAM power supplies for these VRAM chips. There's our EC chip. And I think this one can be programmed through the keyboard header. Actually, the keyboard header isn't there. Remember, I just showed you that. So we'll have to try to figure out how it would be programmed if we're going to do that. And I don't know what that goes to this STM, but I never figured out what those are. I think it goes to the Tron lights. All right, I don't see anything unless you saw something. Anybody see anything? Yeah, I mean, you agree with the glue issue. Let's see, the CPU has a little bit of glue different color, but not as bad. See? That one's a little bit darker, but this looks suspect. or sus, as the children would say. As my 16-year-old viewers, apparently we have a couple different 16-year-olds. If you were here on Sunday, everyone started typing out their age, and we had some 16-year-olds in there. Let me get some coffee. We'll zoom out for a second. Let's we concur. The glue also looks crazy. Yeah, so I'm gonna check for shorts next. That's what I want to do. I haven't done that yet all the way. So we're just gonna hit all these coils. Anything that is a big coil like this is gonna be an output of a power rail or a power supply, and we could have a short on one of those. So we're in continuity mode where you touch the probes together and they beep. And I'll just put one side on ground and we'll just start hitting all of these. So that's a 50 ohm coil output. That's okay. It's going to beep at anything that's below 50. This one is going to be the VRAM, and those are usually around like 20 to 35, and so 35 is fine. Both of those are the same. This one, I don't know what that one goes to, but seems okay. This one's a 20, wait, what is this one? 17? I don't know what this one's supposed to be. 17 seems a little bit low, but you see a chip on the VRAM? Okay, well, I'll take a look at that in a second. All right, CPU's at 4, 3.5, that's fine. GPU should be at like 0.3, that's fine. So those look fine. All right, let's look for this chip in the VRAM. Well, I don't see anything. Yeah, I don't see anything on any of these VRAMs. I think they look okay. So coils are measured in Henry. Well, we're not measuring the coils. We're measuring the outputs of the power supply, power rail. And so if we're going to measure an actual coil, then we would be measuring across it in henries or millihenries probably. But we're not doing that on this one. All right, so this side we have some more output coils. Let's measure those. So we're looking at the 3.3, the 5-volt power rail, the 1.2, the 1.0, things like that. So I'm just going to poke all of these. Still have nothing. So every single coil looks fine. I don't see a short anywhere. I don't see any symptoms on why this thing would not be turning on at all. Let's do our trick where we plug in the power and measure the power rails to see if they come up momentarily, because that also points to an EC issue. So I'm going to measure this rail right here, which I'm not sure what it's supposed to be for, but voltage injection, you can only inject voltage if there's a short. So you have to have something restricting or something that's shorted in order to inject. This board's taking no power at all. I mean, we could like inject voltage past here, maybe try to turn the board on. But see, we're getting 2.5 volts on this side. All right, let me plug the battery in now that we have a little bit of a charge on it. Okay, now we got 10.8 on the battery connector, which means that we probably should have 10.8 on our main rail. We got 10.8 on our main power rail. Okay, so we are energized, so our power rail should be up and running, theoretically. I don't see that, but let me see if we can power it on. I think the power management chip's dead. That's what I'm thinking. If the battery's staying on when we plugged it in, see if I can find a power button on this thing. I think there's a power button over here. Okay, there's a power switch right there. It's just not populated. So we'll just jump it with some tweezers. And let me get onto the thermal camera, actually. Do that. Just want to see if the thing turns on. We're on battery only, so you're not going to see any current being pulled. Oh, I pressed the wrong one. This is the one I was trying to get to. There we go. But I want to see if this thing's coming on. and it's on. It's on. Let me turn it off. Oh. Okay. To recap, here I'm going to zoom back out. I'm going to try to get us a better view. We'll get a bird's eye view. I'm going to plug the battery back in. I know we kind of missed it because I was trying to show it under the microscope at the same time. The IR view is worth it because I can't pull current. That's why. So the reason why we have to do it like that. Because if I had the charger plugged in and I could see the current being pulled, then I would know it's on. But I can't tell right now. So right now it's off. There's nothing going on. I don't feel any heat here. I'm going to press the power button switch. Let me try again. It's hard to press it. But I don't know if it's coming on until I see the there you go. Did that start pulsing? Nope. I thought we saw it turn on, didn't we? There we go. CPU on. You see how it's turning on right now? Now the GPU turned on, all the VRAM. And I'm going to turn it off so we don't burn it out. Okay. All right, so let's conversate a little bit. What do you think is happening here? You want me to check PW3, the chip is cracked. So PW3, PUW3. I haven't seen the crack yet, so, but you guys are eagle eyes. So PW3. PW3, where art thou? Right here, there it is. Looked cracked, but it was just a little hair in the corner. A little hair in the corner. But good eye. I wiped it off. We're good to go. They did power up because we saw them all come on, right? You concur? So in the thermal camera view, which was great, you saw the CPU come on first, and then that kind of pulsed down a little bit. Then you saw the GPU fire up just in the middle, and then you saw all the VRAM come on, and then the VRAM power supply come on. So we know that everything came on. And that's why I love doing that overhead view with the thermal camera. And that's why I love this floor one, because you can actually get the full thing in the view, because the other one was, you know, kind of stopped down. All right, so where we're at right now is that it works with a charged battery. We had to charge the battery on a different machine a little bit just to kind of bring it up. And so now that it's actually up to a voltage that will come on, it's not working off the charger. Why is it not working off the charger? The most probable cause is this little fella right here. This little dude right there, that guy. Because he is responsible for turning on and off these MOSFETs. And he is responsible for charging the battery. Now, if this doesn't work, the machine will still usually run off of a battery, which is great, because then you know the machine's working, it just won't power off the charger or the battery. So we just need to change that guy out, most likely. That would be my next guess here. So what's our chip number? Is it going to tell us? I think it's a 95522AH. 95522AH. And I got some brand new out of my box here, out of Soren's box. What's that called? The Power Management Controller, the PMIC. Power Management Controller IC. So 95522AH. 95522AH. Got a whole bag of them. You concur? They are the right ones. And I'm going to have you guys verify, because I've done this so many times where I pulled it out and then you're like, that's the wrong chip. What are you talking about? That's the wrong one. All right. So we have 9552AH, 95522AH. Concur? We have a new concur emote, so y'all should try that one out too. Or a couple of them, actually. Schematic says 9522AH should be right. We concur. We concur. Concurrence is happening. Concurrence is in order. There we go. There's my concur emote. Okay, I'm going to pull this guy off, and then we'll replace it, and then we should be able to put it back together, and everything works, and then we're done, and we'll go to the next one. All right? Capiche? So we're doing 450 degrees C with 60% air. And I'll add some flux after I heat it up. Love it. Love it. Yeah, whenever I make those emotes, I'm like, I don't even know what I'm supposed to do. I'm just taking like images out of my videos of a screenshot of my face and then just photoshopping it. It's like, I don't know. All right. And the power management chip is off. No NF flux. Yeah, we're gonna have to try to find the NF flux sometimes. Can you show your thermal paste method when you put it back together? Sure. I will definitely do that. This will be, well, they're both kind of square. If these were like different shaped, then we could do the line and the cross, but we're probably gonna do the just the dot and the dot, but I will show you. And I'm not gonna even do anything with that. We're just gonna add some new solder to our new chip here. We're gonna pre-tin it. But I will show you, Black Cadillac. Thank you so much for the donation. All right, so we need to pre-tin this before we stick it to the board, or else we won't have enough solder to go around. There we go. Soda, I pronounced it soda. I want to get some of the, so I have the Black Horse, I think it's Sierra Mike, and then he just made some new stuff. I want to get some of his new stuff. I think it has like beeswax in it or something. Sounds good to me. But use PTM? Oh, you want me to use PTM? Okay. I didn't know if you, ooh. Black Cadillac, did you want me to show you thermal paste application, or do you want me to show you PTM application? Your $10 goes far, so it can pay for a little bit of PTM for them. That stuff's expensive, but I usually want to put it on a board like this. I mean, I guess on the AMD processor I might do. CPU. Yeah, the 559 clone seems pretty interesting that he made. So I'm going to see if I can get in touch with him and have him send some over. So all I'm doing is just putting a little bit of solder on these pads so we are not applying it dry. And then we'll just tap a little bit in the middle. I don't want too much in the middle. It's hard to see that with all these reflections here. I don't know. I think my light's messing up. Do you use blue tack? I've never used blue tack actually. Never have, but that might be a good idea. And when it gets hot, it wants to move around on its own. Now I can't see the numbers on this, so I don't know which way it goes. Kind of make it out a little bit, so I'll sometimes just blow a little hot air on it until we can figure out which direction it is. And I can see that the words are that way, and the dot would be right here, so I think it goes that direction. Pretty sure. Pretty sure, yeah, it goes like that. All right. Solder. So what's a 559 clone? So Amtech, who makes the flux that I'm using, I use Amtech 213 and I use Amtech 559. The Black Horse YouTube channel, he makes his own flux. And so he made up some stuff and he calls it, what do you call it? Something 559, I can't remember. So anyway, it's just like supposed to be a clone. So I'm using 213 right now, Amtech 213, but. So I'm setting it in place, then we'll add our flux, we'll reflow it again, let it kind of dance into its spot that it wants to be in. There we go. You see how the surface tension holds it in place. And then, sorry for the disruption of the show. No, but that's part of the fun. That's part of the fun. So, did you want 559? I didn't get to see. I mean, not 559. Did you want the PTM or did you want the solder paste? Not solder paste, thermal paste. Let's see if I can find your chat here. And then I can see it. Where's pin 1 dot? Now you can see the pin 1 dot. So here's the pin 1 dot on the chip. Here's the pin 1 dot on the board. I did the best I could to see it. Now you see this whole mess of bridging going on here? That's not supposed to be like that. My choice was the best. Okay. Yeah, so what I think we're going to do is on the AMD CPU, we'll put PTM because that's what gets the hottest. And on the NVIDIA, we'll put the Arctic Silver. And I'll show you how to apply that. All right, so all we need to do is just reflow that a little bit. We'll just tap it. I'll zoom in so you can see a little bit more. And with flux, it just flows. So I'm just tapping it like that. And you see everything just separates on its own. I didn't really have to do anything. Now, if I didn't have any flux there and I was trying to do that, it would be sticking and pulling itself around and everything. So, but all the rest of the pins look good. The alignment looks good. And the reason why the alignment looks good is because I didn't have to align it because all the solder surface tension pulled it in the right place. I can just tap it. It will just kind of sit back down. So, okay, I'm going to clean it off, and that should be good. I think it's going to work. I am pretty confident right now, so I don't know if I should be this confident, though. Is that not a good idea? All right. Let's see. La-da-da-da. Let's see. Fingers crossed. Move this out of the way. So this board, I don't think turns on automatically. I don't think it does, but we will see. I can at least put my meter on the main power rail. Let's do that. So I'm going to put the probe, I haven't plugged this in yet. I'm going to put the probe on the main power rail. So we have 0.01 on the main power rail. You can also going to look and see if we have something pulling right there. Will it work? So I haven't turned it on yet, so you guys can vote real quick. Would you ever think of a show on yearly maintenance of laptops? We could do something like that, a live stream of that, yeah. Or just, yeah, even monthly, or have it where it's broken down, where you have like, you know, what do you do every month? What do you do every 6 months? What do you do every year? Something like that. And because, I mean, there's plenty of times people will send in something and I'm like, oh man, they should have just done this a little bit and it would have taken care of a lot more stuff. Yeah, thanks again for the question. All right, will it work? Yes, we got lots of yeses going on, which is very supportive of my work here. How many sourpusses are out there? There's our vote. So I think everyone's leaning towards yes. So again, power meter, you'll be able to see if it pulls any current. I'm going to also be measuring the main power rail, so you'll see if the voltage shows up there. If we have voltage there, then we should be good to go. And cast your vote. All right, I'm going in. You ready? 3, 2, 1. 2.4 volts still. Well, I didn't expect that. Wow. That is very surprising. Womp womp. That's very surprising, actually. So I will change the DC jack just because I want to make sure that we don't have, because actually let's measure our PSID pin. That actually do something. PSID is our communication line with the laptop. And so if there was a broken DC jack at some point and it shorted out to the PSID pin, then we could have an issue with the charger communicating with the laptop. And if there's a charger issue communicating, then it may not power on also. So I want to make sure we don't have a short there. So here's our 20 volts coming in. These are our grounds. And then I believe it's either, yeah, I think it's this one on the end is our PSID. I believe so. That's ground. Yeah, that's not measuring bad. And that is our 20 volts. Okay. Let me grab another jack like I was saying. I'm very surprised, people. Very surprised. Check around the CPU, might be missing something. Well, again, it's turning on the battery. That's what's confusing me. So it's usually going to be some sort of power issue. Uh-oh. Pressing buttons on the keyboard. It's usually going to be some sort of power issue input on the charging that causes that issue. Okay, I'm using my DC jack just for a good measure. All right. Oh, wow, thank you. Thank you for the Prime sub. Probably a commercial came in, and I'm sorry about the commercials. All right, so DC jack's plugged in. We are getting voltage on the power rail here. Power the aliens. This is on the PSID pin. We're getting voltage there. Still not getting voltage here. All right, so here's what we're going to do. We're going to go crazy, guys. Because, I mean, we could have a bad MOSFET here, but we're going to... I was going to thinking about jumping it. Do I want to jump it? Why is there 2.6 volts here? Somebody has something to tell me. Let's vote. Let's change my vote. Yeah, I already stopped the YouTube poll because I was like, here, I'll stop the other one so you don't have to look at it. Yeah, people are voting after it. Yeah, is it going to work? No. Yes. No. No. All right, you already know it doesn't work. Why would it not work over here? That is strange. Let me measure the voltage around the power management chip. All right, so on these chips, we should have 20 volts right here. And we do. We should have our VDD right here. Ah, we're missing our VDD. Missing the VDD, but we just changed out the... We just changed this out. Nope, we got 5.3 there. Okay, what about these guys? 2.6, that seems like a weird number. I don't know what the voltage is on most of these pins. I don't work on the 95522 as much, or I'm not as familiar with the way that all these works, or what voltages we're supposed to have on all the pins here. Like, where's the charger detect on this board? Let me pull up the old board view stuff. Give me a second here. So it's a M15R5 Verizon Edition. M15R5 Verizon Edition. K454? 3? K453. 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 Don't have that one. Well, we'll have to settle for the K454, which is close. It's not the same thing, but it will get us close. K454, because it's the M15R5 Ryzen Edition still. Okay. So here's what we're looking at. So here's our motherboard. And the charger comes in right here. Here's our input that we were talking about. It goes through these two MOSFETs, then it goes into these two MOSFETs, and right here's where we're getting our 2.5 volts, and which is strange. And then if we plug in our battery over here, the battery's voltage is 10.8 volts, and it comes through here and puts 10.8 here, and then the machine will power on. So what we're not getting is our 20 volts to come through here to this part of the power rail. And the chip that's responsible for that is this chip. And so what I want to try to figure out is what we're supposed to have here. So this is supposed to be the 20 volts on the power management chip. And this is our VDD. And so we had our 5.3 here. Where's our charger detect? Our AC, okay, there it is. So we need this to have 3.7 or something like that. So that's what we need to figure out. So the pin that we need to have 3.7 on, this board layout's a little different, but it's the same chip. It's this pin right here. We need to have 3.7 or something like that on there. I don't know exactly what it is. And we don't have that there. So without that, then the chip won't allow the MOSFETs to turn on. So it's a voltage divider. Now, where's that voltage divider at? I don't know, and that board view is not going to tell us. I can tell you that because it's already in the wrong position as we can see. Or no, wait, maybe it's on the other side of the board. Let's see. Okay, it's right here. It's right there. So it's on the opposite side of the board from where we're at. So let's try that. So over here somewhere. And do we see anything suspicious over here? It's going to be PR27 PC. See, they don't label a lot of that stuff over here. That's what's annoying. Here, let me turn this around. I'm just going to rotate this, I think. All right. I'm just trying to get my bearings here. Okay, so it ties to right here. And then, so let's measure and see what we're getting there. You got to plug it back in. I can't see the chat, by the way. Sorry. Because I have the board view up. Okay, so this is where we're supposed to be getting 3.7. What are we getting on the other side? Nothing here. And then what else? Where does it go from there? So that's going to go over to here. Here, nothing. And it goes to this resistor here. All right, so we got 5.3 here, but nothing on the other side. Got 19 volts there. So I don't know exactly where the voltage divider is, or I'll show you what I'm looking at. And again, I can't see the chat. Maybe I can move this over so I can see the chat at the same time. But all right, so we just measured here, 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 right here, and then we got 5.3 right here. So, but that's the VDD that we're getting from the other line. But we're supposed to be getting right here. So we can inject 3.7 there, or 3.5, and I bet we can get the charger to come on. Let's do that. Does that sound like an excitement? We could also figure out what the resistance it is, see if it's open, but I doubt it's open because we don't have anything on either side. So that's measuring low. That one's going to be high. That's going to be high. So I think that we're going to have to inject some voltage. Just what you guys love. You guys love the voltage injection, don't you? So the way I'm going to do it is I'm going to inject 3.7 volts on pin. I think that's right voltage there, right? For this, usually this chip's somewhere around there. I haven't been reading the chat, so I can't really tell. The schematic board view on bad cap, search for Ryzen 453. So they have it there, huh? That has a better layout. Here, give me a second. We'll see if I can find it. Bad caps, where are we at? LAK 453 P. Sure enough, look at that. Got it right there. Okay, cool. I'm just going to get this stuff moved into the right folders. There, should be low. So it shows up as a 5515. That's the thing. And like I said, so it's like a G series, you know. Okay, back on board here. Got it going again. And the pen that we're looking for is this pen. The layout's about the same, I think, but we'll just confirm or concur over here. Rotate that. Yep, so this is what we're looking at anyway, same setup. So this part of the board was the same anyway. I think it was like either a higher end board or had something different. I don't know what the difference on the other board was. So regardless, we need to figure out how we can get voltage on there. And so sometimes what I'll do is I'll just kind of bypass it and just inject voltage on that pin. And so I think that's what I want to do, just for fun. Don't you agree? Don't you agree? Don't you agree? You should open more tabs. Yeah, I try to keep as many tabs open as possible. No, I'm actually pretty organized, so each one of my tabs are there for a reason because I access all sorts of different things. So instead of having multiple windows, I have a lot of tabs. So we're going to inject voltage on this one pin that's missing here, or missing voltage, and we'll just see if it starts pulling current. And so I'm just going to get my power supply going, and we're going to inject 3.7 volts there. And if nobody really understands what we're doing, just to kind of point it out, is that this chip has the 20 volts going to it. It has a VDD of 5 volts, which goes and powers on other chips. And then it's just waiting to see if it's getting an ACOK signal, but I don't see that there. And so if it's not getting that, then I'm just going to tell it that it's okay by putting that voltage there, if that makes sense. So we're just going to take the old trusty, crappy power supply here. Put it. I can't remember. I mean, these other chips, most of the time, it's like 3.7 volts. So I think that's gonna be fine if I do that. All right. So right around there, 3.6. It's a range. It doesn't really care exactly. What amperage? 5 amps. Let's do 5 amps now. Let's do. Why is it at 5 amps? Did I break the power supply? It's funny. There we go. Go down, 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 down. $170 milliamps. You like that? There we go. All right, ready? Anyone good? Anybody warning me not to do this? Forever hold your peace. So I'm going to need a lot of hands here. So I'm going to plug in the charger. Charger's plugged in. You can't see the current because I have my meter up there. So I don't know if I should be showing you the current meter or if I should show you. Here, I'm going to measure the main power rail is what I'm going to have up for you. That's what we're going to do. Okay, so main power rail is going to be measured there. It's measured at 2.5 volts. So once I touch the pin here with this 3.7 volts, with this huge tip, I don't even know if I'm going to be able to get in there. We'll see if it turns on. I can't get in there deep enough. This is the deepest. I feel like I'm touching it though. It's not pulling any current. So that's not working. That's not working. I could do it on the other side of the board, I guess. because there's a bigger surface area. Let me do that. Touch on the resistor. Well, the resistor right there isn't connected to it, so connect on the other side of the board. So I have to touch on the resistor on this side, which is fine. I just have to do it over here instead. So it's going to be this guy right there that we're going to do. Let's try it again. Get everything reattached. Well, I don't really have a main power rail to measure over here, but I'm just going to touch over here. All right, 3.6 is there. What if we plug the battery in to see if it starts charging? It's not pulling any current from the charger still, so I don't know. I could try jumping it on. Chicka chicka boom. Here we go. Nope. That's not working. What do you think's going on? This one's actually kind of stumping me because it's acting really strange, and I feel like there must be a pull-up resistor or something knocked off the board. I mean, are we missing something? Do you think there's something knocked off the board somewhere? Because that's kind of what symptom it's giving me, is that something's missing in the charge area that we just can't see. I feel like we need to do another visual inspection, right? What's the opposite? Oh, is there a short? There's no short anywhere. I can't find a short anywhere. Again, the board turns on battery, so it's not a short. It shouldn't be a short issue. It's more like an open issue. Well, if we did a physical inspection, but it was just kind of brief and we didn't see anything. But if we're having an issue in a certain area, then maybe we'll look at that more. So that's, wait, no, this is the charge area that we were looking for to create that ACOK. It also comes over here, I think, on the schematic. And I don't see any, components ripped off or anything. Check the back for solder bumps. Concur. Any ripped components? Exactly, that's what I'm thinking, ripped components. So I'll sweep around again. You guys just keep an eye out. I don't know. I mean, I feel like there has to be something ripped off at this point. I don't think it's this because it turns on a battery. Did we look underneath this? I mean, unless that power management chip's bad, or I can reflow the power management chip. We can look at the solder job on the power management chip I did. It looked like I did a good job. I didn't do a crappy job, did I? Make me doubt myself. It's not a BIOS issue. That's that power button I keep kind of pressing. Oh, is Dave leaving? Oh, see you, Dave. Yeah, I don't think it's the EC issue because the battery is turning on. What's that? Some scratches, but that just looks like some measurements again in this area. And see, all this is all CPU related, so the thing's turning on, so it shouldn't be over here. Let me plug in the USB-C charger, see what that does, actually. Sometimes these can turn on in USB-C. Where's my USB-C cord? Oh no, my camera's about to die. Darn it. Hold on. So we have to switch to that view. My face cam is about to die. I'm going to turn it off and let it cool off. It's dying because it's overheating. So we'll have to do this one. So I want to see if this thing powers on with the charger. What am I trying to pull up? Try to pull up the power meter. There we go. That one. The meter's not showing up on the screen for you. There we go. It's just sitting at 5 volts. Let me plug the battery in. Because sometimes these USB-C will actually charge the battery, things like that. Turn your AC on. I know I need to go do that. It was actually a little bit cooler today. All right, I can turn this back on now. I've had the camera on for hours because I've been filming and things like that. I don't know. This one's... Did I get bad chips? No, I mean, I've used these chips a lot. But we could grab one off a donor board. I'm fine with that if we want to do that because there's no reason why it shouldn't be working right now. Because, I mean, this is like the thing. This is the main cause of why these wouldn't work. Let me go back to our power management chip just to verify. I mean, all the pins look good. And that's from me trying to like measure in that one area there. The solder job looks good. Looks pristine. And we have it in the right orientation. Let's just, what do you think? Just change it out? I don't know. I feel weird doing that, but I also feel weird not doing that, so. It doesn't make sense why it wouldn't be working. So the battery charge circuit in the main does not work, but it runs on battery. Correct. That's generally how that works. Yep. So again, we can take this battery. I can just put it here. We'll do it under the thermal camera again, just so everyone can see if anyone's joining in now. So we're going to go thermal. So we have thermal going. And you can see the CPU and GPU there. And then if I jump the power button trigger here, CPU coming on, and then wait for it, you'll see the GPU come on. There's a good GPU, and there's all the VRAM came on, and the VRAM power supplies came on, and the EC chip's on. Now the GPU's all the way on. And then I got to turn it off. So I guarantee that it's going to post in this situation right now. The battery's not charging because anything we plug into it, anytime we plug in the charger at all, we don't get any voltage past the first MOSFETs. So if we look, we're not getting any current pulled. So right as we plug it in, no current's getting pulled at all. Yeah. It's on. It's not on right now because you can see no current being pulled. It's just still hot from before. Yeah, it smells like a missing or charging the charge battery area or a MOSFET or resistor or something ripped off the board. I mean, that's really what it seems like. Or it could be a pull-up resistor. In this situation, I went around and just kind of measured a bunch of things, but I have to know what all these values are. And we can also just look for a resistor that has like a dot or a hole, you know? So the way a resistor blows is it usually has like a little eye hole in it. And I don't see any of those blown. That's some flux from earlier. Nothing there. I don't see an eye hole blown in any of these. It could be something faulty with, what if it's a faulty MOSFET, input MOSFET? No, because we already checked to see if it's shorted, but let's see if we're getting any voltage on the gate pins. How's that? I think it's an open resistor or something, or the power management chip. But let's see what voltage we're getting on these gate pins. Nothing. Nothing. So these are all attached together. But the question is, why are we getting 2.5 volts here? Where's that voltage leaking from, right? It's leaking from somewhere or being produced from something. This was going to be an easy one until it wasn't. So it's so hard it's easy. So easy it's hard. All right, I'm inclined to reflow that chip or change out the chip next just to get that done really fast because it's a lot easier to do that. And we have this board actually right here that we just used to charge the battery, so we know the power management chip's working, that we can just borrow the chip on it if we want. Same chip. It will take 2 seconds. So let's do that. Yeah, I could do a Soren jumper if we want. So I can just, who needs these? We'll just put a jumper right across and then that will be it. So let's take a wire, properly calibrated wire, like this. It's properly calibrated, you can blow at any moment. We'll solder it right there and we'll solder it onto there and see if it turns on. You want to do that? We can do that. I mean, it will work. I'm pretty sure it will work. Like he always likes to do, let's come with the power supply. So we can do that. We can come with the power supply. If you aren't getting 20 volts, let me see where your message is. I can't see the rest of it. If you aren't getting 20 volts at the MOSFETs, then how are you going to get 20 volts on the PMIC? So you're getting 20, we're not getting 20 volts. So we're getting 20 volts to the input of the MOSFETs. And we have 20 volts at our PMIC right here. So that's why I want to make sure that we're on the same page of what we're getting. So that the power management chip has its 20 volts, okay, right here. 19.8. Now there's a drop there for some reason. It should be a little higher than that. So we're 19.8. So that might be some sort of suspect issue. And then our second pin is going to be our VDD. So we have our VDD, which is 5 volts, or we did. Where is it at? Where are you at? There we go, 5 volts. So we have both of that that we need. The last thing we need is this pin, which we only have 0.11. I feel like I've seen this issue before. I'm trying to remember what it was. I think it was the input MOSFETs. I don't remember though. If I come with the power supply, I like how he says he comes with the power supply. I'm going to come with the power supply. Yeah, that little wire I had would act as a fuse because it's properly calibrated for sure. I'm gonna do this. I'm not going to put tons of amps in it, but this should be something. Oop. Okay, here we go. You ready? Or I'll put it kind of low. So I'm going to put stuff here. All right, let's see if the power supply is not pulling anything. We're not pulling any current. All right, let me plug in the battery. Let's see if it starts charging the battery. Actually, I wanted to see if we're getting our AC okay. No, we wouldn't be getting our AC okay because we bypassed all that. I doubt it will charge then either. Battery's at 11.3. It's not really charging or doing anything like that. Let me put the thermal camera on it. I feel like something's getting hot here. We have 750 milliamps. So I feel like the battery's charging right now. Yeah, the battery's charging. Might need to go up on my amps just a little bit. All right, yeah, you can see the battery going up in voltage. See, we're at 12.2. And this is being charging off my power supply. So you're not being able to see anything coming out of the power meter at all. And this is bypassing, just so you can see. I'm bypassing the input MOSFETs and just going straight here with the power supply right there. And it's charging the battery. And the machine, I'm assuming, is going to turn on. So why? So that means the power management chip is working because it wouldn't charge the battery, because it did do the negotiation to start charging. I doubt it would be EC corruption because the thing turns on battery. So the next question is, does it power on? I think these input MOSFETs must be busted. Because that's the other thing, is like the voltage is a little bit lower there. Pull the DIMMs. I mean, that's the machine comes on though. I swear it has to be the input MOSFETs. Let's go back to the schematics or the board view and see. I want to see where those input MOSFETs connect exactly. So what I just did, just so you know, I had the charger plugged in here, and then I injected voltage right here, which is the output of these MOSFETs, and that energized the chip and then allowed it to charge the battery here, and it energized the whole board. But what I'm trying to figure out is why these aren't turning on. Okay. So the gate pins on these 4 MOSFETs, 1 and 2. Is this gate pin attached? Well, at least those 2 gate pins come over here to the other side of the board. So let's see where that goes. All right, we need to check this guy out. This area right here is what's is connected to those gate pins that may not be working. I mean, it could be bad MOSFETs. I don't know. I mean, this is stumping me because I've never seen it just be this stubborn. So I can't remember what I'm looking at here. So I think it's right around here. Where was it at? Sorry, I gotta go back to the board view. All right, overhead, here's the SSD connector. This is where all the ACOK stuff is. And then this, see, this board's a little different even. See how there's only one power stage for the VRAM? And we actually have 2. And so it's saying it's over here somewhere, but I don't see that stuff here. Stuff's different. There's the SATA connector. So is it over here? Where's it at? Over here? PBQ15. What is AC, DET, or ACOK pins proper adapter detection voltage? I think, well, you're talking about, it's supposed to be 3.7 on the ACOK. I don't know what it is exactly. We're only getting 0.11 right now. This is the same one, Wes. It was supposed to be quick and easy, and it's not. We don't know what's going on with it. It's acting different than we thought it was going to be. We figured out, though, we can jump the input MOSFETs and it turns on. We figured out you can plug in the battery and it turns on. But we're still trying to figure out why these MOSFETs aren't working. So the gate, I don't see the circuitry here. I don't see that on the board. Unless it's on the other side. Let me check the other board view because this is the one that I just looked up. Oh, look, do you notice that it says, I don't know if you can see it in the view here. No, you can't. Look, it says K453 and 454 in one board view. So it's both of them. Let me go back to my other one that's just a 454 and see what that one does. So someone mixed these together and said, yeah, it's the same thing. I'm like, I told you it was different. Told you it was different. Yeah, this is the same board view. So that was the same board view I already had. Anyway, that's what's fun about trying to fix these things. Okay, BBQ17. So we have that on here. BBQ. That one that's missing. You saw 15? I didn't see 15. I saw 17 though. But it's way down here, which is in a different area than what we were looking at. Let the bourbon out. That's what we need to do, is pour some bourbon. Measure the resistor, divider, ohms for voltage detect on the backside. Well, that's where we're at right now. And I haven't really figured out the exact layout of that. So if I looked for the voltage divider, and the voltage divider, so this is where ACOK comes here. So we should have a voltage divider right here. Right? So where's our voltage divider? Where's our voltage divider? This is 5 volts right here, or 5.3, which is VDD. Or VDD's right here, actually. This is a 5.3 volts. And how is it being pulled down to 3.7? I don't know. We've got an EC connection here. We got this guy right here. ACN. We can look at him. He's next to this SSD over here. One of those guys. Again, this layout's different though, so it's very useless. Oh no, these are here. These are here. So it's going to be this one right here. Oh no. So it says my OBS disconnected for a second, people. So I don't know what we disconnected to. Did we disconnect from YouTube? I just got an error for a second. Did y'all lose me for a second? I don't know. Can you hear me? Hopefully everything's still going. Okay, you're saying PBQ or PQB15 is in the same spot on the board. It's all good. It's all good. Thank you. Right. It's in the same spot on the board. I don't see it though. Where is it? Where is it? Why don't I see it? Oh. I'm going to plug the charger back in. We're going to do some more measuring. We're going to go in a circle here over and over again. Twitch is still going. Got 81 people on Twitch is what it says. Still says 71 on the screen. Oh no, it dropped down to 71. Okay. So I guess I lost some people. So 0.11. 0.11 here. And that's nothing on that side. This is VDD to 5.3. Where's our voltage divider? I just don't see it. Normally it's very easy to see. You're like, this is 20 volts right here, and then you'll have this is ground, and then you have your two resistors, but I don't see a voltage divider. Oh, you saw it. So people are seeing this PB15 somewhere? It's in its place. It's there. Okay, I'll move back over here and I'll just let you admire it. Okay, I see 17. Turn this polarizer. Okay. Go down. Or is down this way? I don't know which way it's down. That's one of those relative things. Down right. So down right. It's written upside down. Oh my gosh. My eyes cannot see it. So should I flip this over then? Ouch. Below 17. Okay. Thank you. So I see 4, 5, see 17. This is the best content ever, huh? Oh, great. Yeah. Oh, someone do a screenshot and circle it and then paste it back in chat. Only the mods can actually paste something in chat, like pictures, but I don't. This is crazy. A little more down. And down is this way. Go straight down from 17. So here's 17 right here. Straight down. Look at that. Look at that. That's the best one yet. Go straight down from... Okay, there's your sign. You know, I was looking for something bigger than that. Freaking idiot. God, you idiot. Thank you. Well, that was fun. I don't really know what we're looking for now. So finally, thank you. This is all part of the content here because it's getting user interaction. No, I'm just kidding. I'm naturally that oblivious. It's natural, I tell you. Natural skill. All right, so charger's plugged in. What I'm looking for here is I want to figure out, I think if we can kind of figure out what we were looking at before, I can't remember. I think these are for the gate pins. Right? So we have our input, and then I was trying to figure out where these go. Those are the gate pins, and those connect over here, and it's connecting right YAR, and then VN's right here. So well, that layout's different. So what do we have here? Nothing, 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 nothing. There ain't nothing going on over here. There ain't nothing going on over here. Let me pull the chat back up because I can't see you. Ha 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 ha. Napoleon Dynamite, yes, thank you. Eat your dinner, Tina. God. John Heater, baby. You're just jealous because I'm getting all the women. I think they should do a Kip Dynamite sequel. I think that'd be great. Right? Don't you think? With LaFonda? Yeah, we'll check the diodes. Check them diodes. How you diodes doing? Those are measuring. Well, that was doing nothing. That's doing nothing, but is that a diode anyway? I don't even know. A dual diode? Eat your quesadilla. Oh, and then he'd be like, no, a little bit, like, to the side. Do a smolder. You have to do the screenshot of that, right? I am completely baffled, you fellows, you people, because that's connecting to the power management chips. I bet I could just inject voltage here and it would turn on too. It's just like funny because it's like, well, why aren't we getting the signal? Why aren't we getting the signal? Who's telling it to turn on? Well, it's that back to that chip that we changed out. So let's just change this power management chip out just to get this out of the way and change it again, obviously, but change it for one that we know works. Even though this one was brand new, if 20 volts isn't reaching, then go back another step. Well, 20 volts. So what we were measuring in that area was these gate pins here, right? So, well, I'm wondering if I just jump this. Here, let's see if we get an explosion when I do this. All right, get ready for the explosion. There was a little bit of an explosion. Let me get a better bite. There we go. Nothing. Oh, something. 0.01. Let me see if I can measure our main power rail and see if it came on. I'm telling you, we could just have bad input MOSFETs or something stupid like that. I don't have enough hands. All right, pressure. But I'm in ohms mode, so that's not helpful. .6 volts. Lots of sparks. Why do we have so many sparks? Why would it be sparking so much? Yeah, I mean, it's sparking because I'm like trying to make contact, but why would it be sparking so much? Should we just jump a wire over it? I'm going to jump a wire over this shit. It's going. We're doing it. This is just for science at this point. Oh no, what was that noise? Oh no, what was that noise? It could be a bad chip. I don't know. But we're gonna use one of these properly calibrated wires. This is a really thin fuse wire, so it can blow pretty easily if we want it to, or if it needs to. And so, yeah, I mean, all that MOSFET's in serial mode, so it's just jumping across. And so, I mean, it has to be, that would mean that these are turning on if we're having a spark getting over here. Because if these are off, then I'm just jumping over to here and there's nothing going on. There's no reason to be sparking. You know what I mean? Or am I off base for that? It's because I'm not wearing my wrist pad, my grounding pad. Darn it, I forgot to put it on. You know, I've never once worn one of those in my whole life. You know what's wrong with this laptop? It's an eBay laptop. That's why. That's what we figured out. That's what's wrong. All right, so we're just gonna do the old deed here. Do the old crazy. And put some properly calibrated wireage on here. Okay. All right, how calibrated is that? I'm just gonna leave it on the spool. That's how crazy I am. No, that way we can jump across if we want one more. All right, are we ready? eBay's and aways. This thing we might be going back on eBay after this. We'll pay it forward to the next person. Perfect. It's perfect, I tell you. Calibrated as F. All right, so I'm just going to measure the main power rail here while we plug it in, and then get ready for screenshots and recordings and all that stuff. Clip that's. Power rail. Look at that. We got 19. We have voltage. So what does that mean? Does it mean we have, these are bad? To me, that's what it seems like. The chip below the wire is blown. Well, both of these are in parallel, so it would mean that both of them would have to be blown. That's what's crazy about it, because they're in parallel. But let's see if it turns on. Or let's see if it charges the battery, actually. Properly calibrated battery charging. It'll probably blow the wire, though. But that's part of the fun. Let's see if we can get it live in action here. All right, I'm going to plug it in. And we're going to see if we charge the battery. Hands-free. Look, Mom, no hands. All right, 0.06. It's going to do pre-charge current. Should jump up to 0.2 and then start charging. No, it's not charging. We have 20 volts there. We have 12.1. Now we're at 1.6 amps. It's charging the battery. Okay, so we're just going to leave it like this. We'll put it back together as is, ship it back, and then he can put it back on eBay. It works great. It's great. And there you go. Bob's your uncle. Let's see if the CPU comes on too. That's the other thing I wanted to see. Can you check the board view MOSFETs on the other ones? Wait, so what do you mean? You should check the board view for those MOSFETs you checked the other ones. Say that again. Rephrase that for me, because I'm not getting something. But we can check the board view on this for sure. I'm going to break this off now. Okay, there we go. Can't be bad to be open. The other end of the wire, I don't have, the other end of the wire was hooked to a spool. The spool was picking up the electromagnetic force in the universe, and that was what was allowing this chip to turn on. We'll just put some UV mask over it and call it a day. So let's try to turn it on now with our bush fix. All right, I'm going to jump it. And we got 0.39, 0.41. The CPU is heating up, and then we're going to get the GPU. Probably not, because it doesn't like that it can't control those, maybe? The GPU did not come on. It probably said, hey, I can't, oh, you know what? The GPU has its own power rail, and I bet that it's not jumping to the right power rail with that setup or something like that. I should wear safety glasses. It's a MacGyver fix. It's a Bush fix, you know? It's like whenever you just got to fix something just to fix it, that's what we do. I'm going to change out those MOSFETs because I think that's what this issue is. So one of those MOSFETs are blown. They're not shorted. If it was shorted, then it'd be working. Because the thing about something shorted means it becomes a wire, basically, right? So if the chip, nothing's getting through, when you try to tell it to turn on, there's two of them actually, and then we just jumped over it, so we basically made them shorted. Then the second set was shorted. Maybe the second set, just flip the MOSFETs around. Yes, that's the old Soren way, by the way. That's what he used to do. Do you remember watching his old one? He's like, I don't know why this isn't working, but we're going to fix this. And he just takes the MOSFET off and puts it back on the other way around. And it basically makes it a shorted wire. But there's a possibility that the power management chip is detecting that one of those MOSFETs is bad and then telling it not to come on. So it could be any of them, actually. But let's change the first set out. And if that doesn't work, then we'll change the second set out. And then I think we're good. And then this power management chip we put on is probably okay, or the other one, the original. So I'll keep it off to the side. Good times. Oh, this only took 2 hours. Cool. How are we going to get through all these? It's just supposed to be like 2 minutes. Heavy Duty, thanks for the Prime sub. And Gritty got some bits. Thank you, Gritty. All right, I'm going to take these first two off Going home early. No, we're never going home early. We have 2 more laptops we're going to do. I wanted to do all 3 of these in the stream tonight. I know people want to see their laptops. We have the other 2 laptops. People are actually in the chat. I don't even know if they're still going to be here by the end of this, but all right. There's my old friend. We'll just put him over there. So these are B02, N04R. I don't think I have any of these. I have donor chips though. What'd be interesting is if one of these are bad. Well, I'm just going to take them both out. I was going to say, like, what if one's bad and it's detecting one's bad, so therefore it's making them neither one work? So theoretically, one of these could be okay. You're going to be here to the end. Wow, that's dedication. I'm actually very surprised on how many people stay for the whole thing. P21, B0N, 21. Trying to find a chip here. I think these P21 N03s will work on here. I can't remember though. So if someone can do a little cross-reference for me, that would be great. Yeah, that would be great. Okay, so this is B02 N03. Don't worry about R. That just means real. That just means that it came off of real. So B02 N03s, P21 N03s. I think these are the same or compatible. I just need a concurrence and I can move forward. Otherwise, I also have B04s, but I don't think that these take B04s. Let me see what this one has on here. Yeah, this one has P21s. So P21 N03s should be the same. Yep, that's what I have here. So this board concurred for me. This board is in concurrence. Concurring now. All right. But do you have Dell stickers? Dell stickers. I don't know how many Dell stickers. Got Parts People stickers. All right, so I got 2 of these fellas. Boom. Concur, thank you. I don't want to have to replace all 4 of these. I don't think I have enough. Yeah, I only have, well, I do. I have 2 there, and then I have 3 here. And then I'll have to order more. Hooray! I don't charge for chips. Everything's the flat rate, so I end up, like, sometimes these chips cost like $8 a piece. It's crazy. Like these power management chips, these are $8 each. Or $8.50. Isn't that crazy? Isn't that cray-cray? Yeah, totes. We got a new sub, new Prime sub, a new commercial hater. I hate the commercials. So mixing and matching is okay as long as we're matching these in pairs. So these are in pair, this is in pair, so I want both of these to be the same anyway. We're going to pre-tin them like before, so we need to make sure we put solder on all these pin pads here before we start doing it. What am I drinking? I'm drinking iced coffee from Summer Moon with my honey, Nate's Honey, thanks to Montgomery. Nate's Honey. It's just an iced coffee. This is the only way I can be at work for 16 hours straight and be able to keep a straight conversation. Or maybe 15 hours. I don't think it's 16, but a long time. I do it for you, okay? Got another Prime sub. Oh, no, not even Prime sub. That's a Tier 1 sub. That's even better. And we're doing good with our viewership on Twitch. We did pretty good last Sunday. We averaged over 100. If we average over 75 for an extended period of time, then I can become a Twitch partner. And they give me a little more perks, which is nice. So that's where we're trying to get a goal of keeping as many Twitch viewers over there as possible. So if you haven't signed up on Twitch, go on over. give me a follow. We did pretty good last week. We broke our follow goal and ended up hitting 1,000 followers. So now we're at 1,050, and our next goal is 1,100 followers on Twitch. I would have never started Twitch without Premise. It was all your idea. Thank you. He's our mod over there, taking care of us, doing the polls and all that stuff, and putting the witty messages on the screens. We appreciate you. I need to somehow reward all my moderators that are here every single week or every single show and spend all that time and energy answering questions and helping out. Okay, which way does this go? It goes like that. All right, we're going to heat the board up, preheat the board. Try to get this flowing. We're just going to tack these in place, and then we'll reflow them with solder or with flux whenever we get them installed here. And I'm blowing the heat away from these connectors. You see I have the DC in jack here. We have that audio board connector there. I don't want the air to be blowing off at that, so I'm being very, very weary of that. Put that over. Thank you, Premise. You're the man. Or woman. I have no idea. There we go, just tacked them in place. Once they're tacked, then you can worry about trying to straighten them out. I don't want you to get all uppity about like trying to get this thing all lined up right away. You want to kind of just get them tacked with the solder tension, and once they're tacked, then you can come back with some air, reflow them with flux, and then you'll have it seat in place just the way you like it. Like that, see? Nice and pretty. Just the way it likes to be, okay? So at least that's how I do it. Some people are going to be a little bit more meticulous when they're installing the chip right away. But again, when you just put flux on there, try to use the hot air, it like blows the flux everywhere. So it's easier to just heat the solder enough where you can set the chip down in any orientation you want, then add the flux and then reflow. So I'm going to let it cool off just a little bit, and I'll clean up this mess. It took 2 hours to fix the laptop. Well, it took me 3 hours finishing shading up the upper lip, shaving your upper lip. Wow, it's crazy. Is anyone doing Movember this year? Do we have mustaches? I almost tried to shave into a mustache, but I was like, I don't know if I can pull that off. Do we have any Movembers? You don't do Twitch? That's fine. That's fine. I appreciate any support you have. I was just we're just trying to balance it out a little bit, so not a big deal. All right, moment of truth. So we have that on there. Let's measure the main power rail at the same time for the explosion. Okay, here we go. 3, 2, 1. 20 volts. Boom. Look at that. Who would have thunk it? Not me. Not me. I was not thinking that both of those MOSFETs, I mean, there's two of them. There's redundancy. But I guess if one blows and then the other one's having to work on its own. So we kind of had a false positive that it was the power management chip that was the cause the whole time, because the power management chip is what's in charge of turning on and off these MOSFETs and controlling those. And so the fact that both of those weren't working really threw us for a loop, and we went down, I don't know, I'm sure you can go back and look and see how much time we spent on this, but we concur, everyone's concurring. So let's let me plug the battery in again while we're on the bench. I just want to see it start charging before we proceed. So, and then I'll reassemble it, and we can see the Alienware screen, and we can go to the next laptop, which I think is the Latitude. So I have it plugged in. We got pre-charge current. Well, it should be at 0.22. I don't really understand why it's at 0.06, but someone totally called it 2 hours. I'm telling you, it's all about engagement, people. It's all about engagement. All right? I got you to stay for 2 hours. I pulled you in for that 2 hours. If I fix it in 5 minutes, then you'd be like, well, that's boring, man. Well, that's too easy. That's what she said. That's what she said. Okay, just gonna clean up my mess. I hate a mess. I hate a mess. Bam, charging. Okay, it's charging. We'll reassemble quickly, and then I will throw it aside, and we will start on the Latitude 5411, which is a really cool laptop. It's really cool looking because it is spray painted. It's like a street artist spray painted it. Pretty cool looking. So someone, it's one of those types of laptops where you're walking down Fifth Avenue or whatever in New York City, and they were like doing the street art, and they're like, hey man, can you totally just put some vibes on this laptop of mine? So that's what the laptop looks like. Okay. So we need a heatsink. So we have some PTM we're gonna do. Look how dirty this counter is too. Ugh. Sorry, I can't handle it. Can't handle it. Don't forget the shims. Tuition is how much? This tuition's free, so you guys can come here anytime you want, but you can support me however you want. Donation driven. Okay. You can't find any repair videos for a 7506, so if you go on there, you may find a 7706 or a sister system. That's what you need to look for in those, because sometimes it's one of the situations where we didn't do a video on all those, or we're not getting enough demand to do a video, because we have a backlog of videos being done for tutorials. And so if you don't find the 7506, then you need to find something that's similar, like a 77, which would be the 17-inch version, or 74, which is a 14-inch version, and the layout's very, very similar on those, because they basically use the same motherboard. It just has a wider daughter board or something like that. So that's what I would do. All right, so this is how I start when I'm doing this. Remember, because we're going to show you how to do thermal paste. So I always scrape off. I use one of these plastic scribes, and I scrape off all the old thermal paste like that. And same thing I'm going to do here is I'm just going to use this, and I got to be careful on, well, this one's not even crunchy. Usually it's crunchy, but I'll use this to kind of pick up any on here. But on a GPU, there's going to be capacitors, so you have to be careful. So I kind of do it at an angle here. And on AMDs, there's generally capacitors, but on Intels, there's not going to be any capacitors around the CPU area here. So I just kind of pick up as much as I can, like that. You just don't want to break a component off. That's why I'm using a plastic one anyway. And I have a special one that I always keep aside for that because it gets so dirty. And then we're going to clean this off. We're going to use some isopropyl alcohol until it's wiped clean. Appreciate the content. Thank you so much. You guys, anybody who's in town can come and visit anytime you want to, by the way, because we are open 10 to 6 Monday through Friday, and I'm in the store most of the time, so you're welcome to come and meet me and do all that. We can talk. We have plenty of people come in all the time. All right, so I have the dies clean. I don't have the rest of it perfectly clean. It's, you know, we can sit there and spend time. If you want to get that perfectly clean, the best thing to do is to use a toothbrush, isopropyl alcohol, and just lightly do it, and then wipe it off, lightly do it, wipe it off, lightly do it, wipe it off, and you can get through all the cracks. We're not going to do that right here. We don't need to. So we're going to put PTM on here. We're going to put just Arctic Silver right there. So here's our PTM 7950. Right here, this is the Honeywell version. And we actually just ordered some from Thermal Grizzly. We have a new contract with Thermal Grizzly, so we're going to start selling all the Thermal Grizzly pads and PTM and all that stuff on our site. So, but this is the Honeywell's version. And the way I do it usually is I just kind of find a corner that lines up, because this is a huge sheet. You're not usually going to get a sheet this big, but you see the dies right there. So I just kind of hold that on there and I just try to get an imprint. So I'm just going to rub on the die. The die is the only thing we need to put something on. And so now we actually have like a little bit of an imprint there, you can kind of see, and we're going to use some scissors and cut that out. So if you don't live very close and you want to come and visit, there's plenty of music festivals that happen, so there's always an excuse to come down here. That's why most people will visit, like for South by Southwest or ACL, Austin City Limits. There's huge bands that come and all that. You notice I didn't even cut that very square. It doesn't really matter. That's not super, it doesn't really matter. Because all I want to do is kind of overflow over the die itself a little bit, but not like, it doesn't need to be perfect on the die. It can be overflowing. It doesn't really matter. So there's two different sides that peel off. One I think is thicker, or one's not. I don't know. I usually just peel whichever one peels off easy. Like that, and then we're just going to stick it on there. There we go. So the main problem that you'll have here is it coming undone when you're trying to pull it apart. And I can actually kind of scrape this with my nail and try to get it to match the die exactly. So when I peel this off, it will leave it right on the die. Or you can just try to be careful and just try to peel it off. I usually use tweezers to get this top layer off, but it's really hard. There we go. Nope. Try a different corner. Peeling it. There we go. Peel it, peel it, peel it. All right, and that one's off. There you go. So that's it on that one. So the PTM is installed. And then for this big giant die, this one's a lot bigger. I'm using Arctic Silver 5. This stuff's good. These don't get as hot as a CPUs do. And in general, you could just use Arctic Silver on this die, but it's fine. So what I do is an X method on here. So I'll start in this corner, and I'll go all the way over, and I'll go all the way over here. And sometimes if I'm inclined, I'll do a couple dots like that. And that's it. I don't spread it, I don't do anything like that. And you'll see that this isn't going to overflow everywhere, but it is going to cover the entire die. And that's what you want. You don't want anything on the green, really. You don't. I've seen it where people have filled it up where it's covering the whole green, but that's not what you want. So, so those are the two ways I do it. If I was just going to do this one, I would just do one line right down the middle. Or this is kind of a square, so maybe I would do a little bit of an X. But when they're usually long and skinny, I just do one line. So, all right, let me see if we have any questions before I put this on here. Oh, man. Sorry. Let's see. Pretty often, prefer thermal pads. No videos on the 7706 or the 7406 either. Funny. Oh, gosh. I'm trying to think of something else to look at. I don't know. Those machines are just a pain in the butt anyway, because there's two different versions of those. That's the other problem too, is a 7506, 7406, there's a silver version and a black version. Totally different machines. So that's why they call it 7506 black, 7506 silver. Totally different machines. So stupid. So that's why we have different categories for them. So maybe that's why it's like that. PTM will liquefy under the CPU when it gets hot under load. Yes, it's a phase changing. So as it gets hot, it starts to liquefy. So we're just going to line this up here. And here's something else that I do that I don't know if most people do it or not, but here's what I do. So I have it lined up with the screw holes, and this one doesn't matter as much because it's PTM, but the Arctic Silver, I'll press down on here, and I usually will slide it back and forth a little bit while I'm pressing down. And that will kind of mash it and then kind of make sure that it's spread enough just to line up the holes. And then that will, I don't know if it helps or not, that's just something I end up doing. Is it okay on the GPU? The GPU looks great. Yeah, what we put on the GPU is perfect. Do you think I need more or less? Because you could do the whole spreading of the spatula thing, but you could put a dot right in the middle, but the dot will maybe not spread out on a big die like that, so that's why I do the X method. Great, my freaking camera's about to overheat again. I don't know why, the overhead camera and the space camera are the same cameras. They both have fans on the back of them. Maybe it's because my AC, yeah, I need to turn my AC on, I think. So I'm gonna turn this thing off again. Twitch subscriber, new Prime sub, thank you. Fans look clean enough. The fans look clean from here, but we can look inside the fans. I don't know how fast we want to go on this because we can just turn this on, make sure it works, and then move on, because I'll do my final. There's the camera's too hot. Oh, God. I'm going to throw this camera out the window is what I'm going to do. I literally have a fan bolted to the back of the camera. Literally. And I don't say that lightly. I say it literally. Turn on the AC. Yeah, my face cam died. Yeah, I know. That's what I'm saying. And I don't have my other one set up. I wonder if I should have set it up where I can put my other one on that corner. Yeah, my AC is on, but it is hot in here, so I'm going to let that cool off for a second. Whew, now I'm feeling hot thinking about that, so I can do that. Hello, hello! Let's see. Trying to see if there's any other questions while I'm doing this. Oh, we were going to open. Do you want me to open the fans and look in there or not? They look pretty clean. I mean, I bet there's probably some sort of fur in there, but for this, what we're trying to do right this second, we just want to turn it on and move on. Because we've already spent 2 hours and something on this. And I forgot to put the shield on here, which goes around the GPU. Forgot to put that on there. So when I come back in the morning, usually I come back and finish everything properly. I do it proper good, the proper way. But what I'm doing now is quickie. It's just a quickie. The VRM pads, there was already VRM pads on there. So I didn't see any issues with them. And I usually don't change those out unless they really need to be changed out. Put liquid metal cam on the cam. Oh my gosh, no liquid metal. No liquid metal. That's a pretty good PTM 7950 on there. All right, this should be cooled off by now. It's weird because I just turn it off for like a minute and it's fine for another hour or two. So I gotta boot up. Hi, it's working again. It's magic. It's like magic. Just a couple happy screws and then we will move on. What's the average lifespan of thermal pads before it gets too dry? So the stock or thermal pads you're talking about, like for the VRAM? I don't know. Those I don't change them out very often. Let's just say that. I don't think they are a big issue. Thermal paste, I would say 3 years or so. You should paste every 2 to 5 years, and that's depending on like how much you're using it, you know. I'll put our test battery in there. We got 2 months. Richard, 2 months. You the man, Richard. All right, can't screw that in because there's already screws there. Okay, plug it in, move on. Okay, got the battery plugged in, got the charger plugged in. But I didn't plug in the power button. We need the power buttons. Forgot to plug in the power button. I like how we jumped that first MOSFET with a little properly calibrated wire to figure out that we need the MOSFET to be changed out. I might use that in the future. You know what I mean, Jelly Bean? We got keyboard backlight. I can hear fans blowing. We have the alien head. And we got bits. Man, it's all coming together. It's all coming together. Thank you so much. Come on. So 1.7 amps, that might be charging. Press the power button again. Still coming on. CMOS reset takes a little bit of time, so we have to give it a little bit of time here. Do we have an error code? Hopefully it's a 3.1. A 2.1? Is that what you just saw? Don't you tell me that. Yeah, the donations go towards the laptop repair. That's correct. Okay, it's turning off and turning back on. Two, one. Well, we all know what that means, right? It means it was a waste of time. It means bad CPU. And that's the story of the life of this is the AMD CPUs. One, hold on. I still haven't seen the 2.1 yet. I just 1, 2, 1. Yep. Oh dear. Okay, so that means we're going to the next computer. So we spent 2 hours and a half, and we got the machine to come on off battery. We got the machine to come on while jumping the fresh MOSFETs. We got the machine to come on after we changed out the power management chip and replaced the first input protection MOSFETs. Why did the protection MOSFETs blow out? I don't know. And then once we did all that, the CPU's dead. So that might be the cause in the first place. So 2.1 means bad CPU. Unfortunately, that means that maybe I'll have to send this over to Black Horse and let him change out the CPU. What do y'all think about that? So I'll have to get in touch with the customer on that one, and we're moving on to the next one because that was a waste of 2 hours, 2.5 hours. Reflow the CPU? Do you think that's the trick? Who wants to reflow the CPU? Should we reflow the CPU and see if it fixes it? I don't think it will, but I think someone said that those AMD GPUs have bad pads underneath. We got a yes, do a vote. Reflow the CPU, vote, go. It won't take that long for us to do that, so that's why I'm like, well, we could do that, I guess. I don't need to put like a big preheater on or anything like that, but you've invested so much time, why not? Next machine. We got a next machine, and we got, no! Another eBay bargain. I feel like we should go to another eBay bargain, and then I could reflow the CPU. We could save this one for the Sunday stream. We can reflow the CPU on Sunday. How's that? Y'all want to see if we can save the CPU on Sunday? Sunday CPU saving. So I think we should go to the next one just because we have other people in chat that are waiting for theirs too. Sunday, Sunday, Sunday. Okay, we'll do that. The Sunday Revival. Thank you, Mr. Wonderful. You're wonderful. All right, so the next machine is the Latitude 5411. Latitude 5411, purchased on eBay also as well. Look at this guy. Bro. What are we talking about here? Look at this. Isn't that sick? So this is spray painted. Smells like spray paint. So this is pretty cool. So this is almost like a street artist. They were walking down New York or something and had someone spray paint it. This was also an eBay purchase. Here's their note. It said purchase machine off and eBay will not boot. Power button LED lights up, stays on for a couple seconds, shuts back off. Tested the RAM, it works. Contains an NVMe, no user data. I would love to see it repaired live, right? And don't worry about scratching this. So that's pretty dope, huh? So the inside looks normal, looks normie. It's the business machine. These are great machines, actually. And let's see what it does. So we just need to update the title. Yeah, pimp my laptop. One more thing, you've been pimped. So Latitude 5411, psychedelic machine that doesn't post, I guess would be it. You've been officially pimped by XYZ exhibit. All right. Try to power it on. 0.01, nothing. 0.01, nothing. 0.01, nothing. So every time I press the power button, it just kind of goes up 0.01 and it goes back off, and we don't have any charge current or anything like that. So let's open the bottom up. Let's open the bottom up and take a look inside. Need a new screw bend here. What causes CPU and MOSFETs to fail? Heat, of course. Heat. So CPUs, I mean, you got a lot of current going through these things. They're powering the CPU. They have a lot of heat. There's little chip coolers and there's pads and there's things to try to keep it cool, but they'll still overheat in the long run. So everything, it's heat related. So keep the laptop clean, keep it cool. And I'm just seeing a lot of the AMDs having an issue. And so somebody told me on one of the streams that they said that they had an issue with that same type of board and they just reflowed the CPU and it fixed it. So that, I'm interested in trying it at least, since we have nothing to lose. Heat is your enemy. Yeah, there's some sort of exponential curve if you look at like heat on capacitors even, and for like every 10 degrees, it like doubles the risk of it, you know, being damaged. All right, and the bottom is open. So this machine does have a CMOS battery. The symptom I'm seeing could be a frozen BIOS, so the first thing I want to do is I want to unplug the CMOS battery and remove that from the picture so we don't have any power on the CMOS. Now we'll plug the charger back in. The machine should automatically power on when we do this. 0.01 and off. Okay, so it's not doing that. Let me take out their NVMe. We're gonna take out the RAM. Don't scrap the paint. I think it said you can scratch their paint. I think they wanted me to scratch the paint. I'm just kidding. I'm being careful. I'm going to take out all this stuff here. I don't want to have anything that could cause the board to be shorted out. I'm going to take out all these different components here. Your Dell G3 3500 just died. That's no good. One thing I hate about these types of machines, they have a middle frame. I don't like laptops with middle frames. It's just like another piece of plastic that Dell puts in here so they can fit different batteries in different brackets. Did the paint get in cracks? Oh, that's interesting. That's interesting. I wonder how they painted it. If they painted it with it on, it looks like they took the cover off because otherwise you would have had paint coming through here on the fins, but there's no paint here, and there's definitely been painted here. So this was taken off and painted. So it definitely wasn't some street artist that did it. I'm gonna try plugging this in again. All right, so this time we went up to 0.04. let's try our USB-C meter instead. 20 volts, 0.04, 0.04. Okay. So our USB-C meter is giving us a little bit more indication of what's going on. You see how it's pulsing? So it's going to 40 milliamps, shutting off, 40 milliamps, shutting off, over and over again in a loop. So I bet we have a short somewhere, and the thermal camera could reveal itself. And the CMOS battery is disconnected. Everything else is disconnected. I've disconnected as much stuff as I can. And let's see if we can see anything pulsing. Some of these things are reflections. It's pulsing, but I'm not seeing it pulse. We're probably going to pull the board out. Yay! More watching people unscrew stuff. It's my favorite. And then the other thing again was battery. Try plugging in a battery into it. I don't know if I have a battery readily available for this machine. Takes one of these connectors. Open it up for physical inspection. Middle frame, let's go. We'll start taking middle frame out. I hate middle frame. Water cool. Wait, is water cool or fan cooled better? I don't know. For desktops, right? Not for laptops, obviously. I went with an air cooler in mine, personally. Just less things to deal with, but I'm not also trying to run something super hot or anything. PD controller could be the issue, but this thing has a barrel jack too, so that's why we're using the barrel jack. Does the same thing. So check out barrel jack right here. Plug it in, 0.03, shuts off. Unplug it, plug it back in. 0.01 this time. 0.03, shuts off. So it's kind of doing the exact same thing. So to me, it seems like the PD controller or power delivery chip, which is the USB-C, and the barrel jack are both tied to the same power rail that is trying to turn on and then noticing there's something shorted. I'm assuming that we probably have a short like on our 3.3 or our 5-volt power rails, one of those two. That's my guess. And I'm thinking we might have an easy pizza. The pizza might be easy, or easy burrito. And I love secret screws. And Premise concurs. Our blue board's junkier than green boards. I don't know. I mean, Latitudes are higher end than in general, but it depends on which plant or manufacturer made it. GCE or assembler, I guess. The ODM still are the same ones, but it's like you have the assembler of the board, and GCE is one, and I can't remember the other ones. But that's why you'll have different components and stuff like that on there. You need a quantum screwdriver. Yeah, an entangled screwdriver that can just take everything out. The board's in the machine and out of the machine at the same time. We can do Schrodinger's cat of a motherboard. The motherboard is alive and dead at the same time. Similar coolant in your car. Yeah, for the liquid cooling. You just got to be vigilant on how the cooler's set up or where the radiator's set up, because you can get air bubbles and you just don't know it. If you're like, I'm going to lay down my PC now in my cabinet or something like that, and then your water cooler is now getting air bubbles. I don't want to take the heatsink off. I just want to pull this thing out of here. Don't make me do it. Okay. And the motherboard is out. Okay. See some dirt here. Do we have any liquid spill? It kind of looks like something. No, it's just dust around the fan. That looks like evidence of something. Oxidation, milk, latte, little latte action. Do you think we have a liquid spill? Think we have a liquid spill? Aha! Aha! Might have something. Yeah, there's something there. I may need to take this heatsink off after all. I was trying to get away from not having to do it, but we must do it. Let's see. Oh, come on. Oh, man, this fan connector does not want to come unplugged, I'm telling you. And we don't want to rip the wires off. There we go. Got it. Latte. I'm telling you, it looks like a latte, doesn't it? Thanks a grande, have a latte. Or thanks a latte, have a grande. That's what it is. That's the joke. And the heatsink is off. So we have fresh thermal compound on here. So someone has been in here enough to re-thermal paste it. It's nice and juicy, milky, latte-y. Just gonna pull that off of there. Oh. We having fun yet? Okay. So just quick look around. I do see that liquid damage in this area. We did see it on the base itself. I don't see it on that side. See if we have any other corrosion. And we should be able to just plug in the charger now and see what's taking that 40 milliamps. There's some more liquid damage there, possibly. Something. Nope. Okay, that's the back of the CPU. I'm going to flip this over. Got all of our power stages. There's our chipset. There's our BIOS chip, usually next to the chipset. SD card. You can see something here. I mean, it's very minimal. What I'm seeing is not too bad. Yep. But you see just a little bit. Like I'm just barely being able to see. If I can get it in focus for you. But you see how this part of the capacitor looks like this, and this part kind of looks dull. And you can kind of see some stuff on here. I don't know if someone's been in here and just like tried to clean it, but it does look like we've had some liquid damage here, even. Maybe a little bit there. Yep, there's some corrosion right there. More corrosion right there. All right, so we have a liquid damaged laptop. Hey, my favorite. Why don't you just throw it in the ultrasonic cleaner? That will get it all fixed up for you, right? Oh. Well, that is one way of doing it, but the problem with cleaning a board that has liquid damage on it is you clean off all the liquid damage and then you don't know where the liquid damage was. So it's not a good idea in general to do that. previous owner might have had some funny powder on his table. Some left-handed powder, of course. All right, so let's go thermal. So I'm just going to plug it into the USB-C port, and we're going to go thermal. We'll sweep this way, and then we'll turn it over and sweep that way. We're going to see something. Going thermal. 3, 2, 1. It's all reflections, reflections, reflections. Reflections. We see the chipset. No, I think the chipset was on, but it's not. This one definitely reflects more than that other thermal camera. I can tell you that. Yeah, I don't think it was overspray because we checked that. I'm going to let it sit in one position. I want to see where that pulsing is. We have to have pulsing somewhere. Let me turn my light off and see if that helps the reflections. Do we see it pulsing? It's like staying in one position. See, that's a reflection in that corner. I'm going to move down. One thing I am noticing, the power light is coming on right here. See that little blink? The power light is blinking on for a second, so that's what could be pulling the 40 milliamps. So, let me pull this plastic cover off. And this is the EC chip right here. Stand still. Here, I need to get my hands kind of in the view or else it starts changing its range. See, if I move away, then everything kind of gets hot. If I put my hands in the range, then it keeps it in there. Let me flip it back over. I feel like it's around here somewhere. Oh, anybody? Anybody see anything? You swore you just saw it? I mean, I keep moving around is the problem. But I mean, like even the chipset looks like it's on, but it's not. See if that's a reflection. I tilt it. That's what I'm saying. That's the only problem I have with this one is it reflects so much. I have my light off too. All right, let's do the DC jack instead. So I'm just going to do the actual DC jack. Power button. Now on the DC jack, I knew that we kept pressing it, it would turn on. You saw oxidation in a couple spots. All right, so we have a couple different things to think about. Well, let's measure around and see if we have any shorts anyway, because that's what we're gonna have to do. But a couple different things to think about is we have liquid damage, so it probably could be a short somewhere, or messed up Easy Pizza somewhere. Went back and flipped it. There was a pulse. So did someone see the pulse, you think? I think that, I mean, it's only 40 milliamps, so it's really hard to see, but it was also pulsing with the light, you know, where the light is right here. Wait, that's the power button. Wait, is that where the light is? Yeah, so the light's right here on the power button. So if I plug in the DC jack again, and press the power button, it's not doing anything. I could try a polarizing filter. That's a good idea, actually. Let's see if I have some more polarizing film. me try that. So the lights are going through a polarizer, and then our view through the microscope is going through a polarizer, but the thermal camera is not using a polarizer. Let me try that real quick. Oh. So here's some more polarizing film. I'm just going to put a piece in front of there. So cut just a tiny little piece, just a happy little piece to put in front of the thermal camera. See if it does anything different. Thermal polarizer, yes, that's what I was talking about. Going thermal polarization. Okay. Thermal camera has a polarizer on it, and I'll rotate it. Ooh, psychedelic. Psychedelic. Okay, let me go with this other, let me go 90 degrees to that. Well, it looks like the camera's getting through, but I don't think the thermal's getting through now. That's what it looks like to me. Looks like the thermal wasn't being able to get through there. Freeze spray to check. That's interesting. Freeze spray. I don't know if freeze spray will be a good. This is the new old camera. This is my old thermal camera. I returned the other one today, the P3 Pro, because nobody liked it, or most people didn't like it. And I only had a couple more days to return it. But I'm going to measure some of these power rails. Measuring power rails, go. Actually, I want to measure for shorts. That's what we talked about. Let's do that. Let's measure for shorts. Just get that out of the way. We're going to check all these coils like we do every single time we're measuring for shorts. Put it in the freezer for 3 minutes. That's a good idea. What will we do for that 3 minutes, though? I'm sure we can figure out something. I actually have some pretty fun little thing to show you later, but that's on our closing segments, of course. So I'm going to check all these coils again. We're just going to see if we have a short on a coil. 5 ohm. 5 ohm. So this could go to the CPU. We have these three here. These are 2 ohms, or 1.3 ohms. This one's 4 ohms. This one could go to it. I mean, they look similar. What about these guys? 14 ohms. That's a little bit low for the chipset, I would think. What about this one? That's memory, probably. That's fine. That's fine. That's battery, I bet. Okay. CPU's dead. Call it. Go next. You're so funny. I'm going to plug in. I want to measure voltage on the BIOS while we plug it in too. So I'm measuring the BIOS right now. Nothing. Can you give me schematics for a Lenovo? Thank you. You're asking me? You're asking the wrong person, man. I don't give schematics, period. I would never give anybody schematics because I don't own schematics. So that's something you have to go find in your own resource. B, I only work on Dell and Alienware, so I don't have a Lenovo stuff. But you can go on Bad Caps and find it if you want. Correct? Correct. You're asking someone in chat. Okay, that's cool. This is such a funny little thing, this little blink here. Blink, blink, blink. I want to get a battery. Can I get a battery? Do you mind? Let me find a battery. Find a battery. Do I have a battery? I have so many batteries here. And I label most of them. I don't work on a lot of Latitudes, funny enough, because Latitudes never fail. Not never, but they usually don't cost that much to fix. What does this go to? There we go. Is this 5480? Is this one gonna work? There we go. That plugs in, I think. Okay, let's see if we have voltage on that connector. .8 volts. This is a 2-cell battery. Yeah, this is a 2-cell battery. That's why it's so low. 6.8 volts. Now I'm going to plug in the charger again. Wes was asking something. Wes, what are you asking? Let's scan for damage, then scan for damage. Did those boards come in yet? Oh, no. I don't. They might be on the dock. Unless, yeah, I haven't, they didn't come to me yet. I haven't seen them at my desk yet. So, no, I haven't seen them. But I will keep an eye out. Thank you so much. Okay, so we have the battery plugged in. And now I have the charger plugged in, the USB-C charger, and we're not doing that pulsing anymore. Which is interesting. How long have I been soldering? Since I was 10 years old. I got my first soldering iron when I was 10. Yeah. Been doing a lot of soldering. But I didn't have a first hot air station until about, I don't know, 12 years ago or something. Maybe longer. To find the tracking number. Let's see why it's taking 6 days. Where's it coming from, Wes? Okay, we got something going on here. Look, the power light's staying on now. Do we have heat? And that's really hot. So this is actually coming out of the battery that's causing this heat. That's right here. Plug it back in. Yeah, so it's running off the battery right now. But the CPU is not on, and the chip that's getting hot is this one, which I think is what controls the VRMs. What is my laptop daily driver? I use a 9500, XPS 9500, which is XPS 15, it's a 2020 model. And then I also have the older XPS 9560, which is like a 2017 model, and I have Linux on that one. I don't know why this is hot. It's getting hotter by the minute. And this is off a battery, of course. The power light or a charge light? It's the power light. So if I open this up like this. All right. So you see the lights on right there? So I'm going to unplug the battery. So that light's off. If I plug in the charger, the light just blinks for a second, shuts off. So it's like it doesn't want to stay on. Okay. And if I do it with the USB-C, it just pulses every couple seconds. Okay. So now I'm going to plug the battery in. It's not doing what it did a second ago. It stayed on before. I have to plug that in all the way. All right, let's try it now. So now, when I press the power button, it stays on when the battery's plugged in all the way. And you notice it's not pulling any current from here. Again, similar issue, right? So it's like powering off of there. We don't have memory in here. Let me put some memory in here, because it may actually turn on the CPU if we put memory in here. All right, back to thermal. It's a multiple phase chip, yes. So that NCP should be controlling all the power rails for the CPU. Reset this. Okay, on battery, if I press the power button, it turns on. So I only need the charger plugged in to do that. And the CPU is not getting hot, but that NCP chip is getting hot. With RAM in there. Oh, well, I don't know what voltages we're getting. Sorry. I'm just going to measure around, because if we're getting some voltage, the CPU, we got 1.2 for the RAM is on. We have our 5-volt power rail, and I'm assuming this is 3-volt, or 3-volt power rail. So we got 3, 5, and RAM off of battery. And we're just not getting the CPU to come on. So we have an issue on our input power circuit again, probably. Or we have a BIOS issue, maybe. I don't know if it's a BIOS issue or not, but we have a spill, so we should have something wrong with the input somewhere. We have that spill evidence here. So I think we need to find a short somewhere. Where's the PD controller? There's the TPS chip. Let's measure over here. Something's pulling it low. Something's causing a short somewhere. Something's telling it, no, shut back off. All right, so here's our TPS chip. This is our PD controller. I'm just going to measure around here, see if we have any shorted areas. Nothing there. Measure there, nothing there. So our input jack. So this one only has one MOSFET it goes through, then it goes through another one in series. In serial mode, as Soren would say. So it goes through here, then comes out of here. And then, where's the current sensor resistor on this thing? So it comes out of here, comes down this trace, goes over here, following the leader. Okay, so it goes over here. So these are going to be, that's our current sensor resistor. And then, let's check these guys. These MOSFETs. So we have a shorted MOSFET here. 1 ohm shorted MOSFET, input protection MOSFET. That one's fine. That one's fine. So I think this guy's bad. Because, so I don't know if you followed that. I just kind of did it without really explaining myself. But so when it comes in through the DC jack here, and it comes across, it goes through these inductors right here, and you can kind of see the trace, kind of. It goes into this MOSFET, then it comes out of this MOSFET and comes in here, this way. Oh my gosh, I'm trying to get lined up here. And let me get that out of the way, there we go. Or are these in parallel? Can't see this one. Comes here. Can we see that right there? Oh yes, okay. So it comes out of here, then comes out of this. You can see the trace goes across here, goes into this side right here, comes out of here. So it's coming out of these three. Okay. Then this trace comes all the way over here. Just keep following it, following the leader, all the way down here, all the way over here, through this current sense resistor. Then it goes through these two inductors, and then it goes into this MOSFET, and then it goes to this coil, and then it goes to ground. And then this is the main power rail. So what it's trying to do is it's trying to produce the power rail this machine is going to run at, which this one is a, the battery is like a 7.4 volt battery. So this main power rail is going to be 8.4 or 8.6 right here. So this is going to be pulsing like that, and it's going to reduce the 20 volts down to 8.4 or 8.6. And when I measured the gate pin here and the drain, we got 1 ohm of resistance. So I believe this is bad, or the power management chip is bad, which is going to be somewhere. Which is going to be somewhere. Oh, it's right here. And we can easily check this one because I'm pretty familiar with this chip. The left chip looked deformed. The one that I scratched on. I'm going to check voltages on the power management chip just because I know what we're supposed to have. So we should have 20 volts on this corner right here. We got 19.4. That's wrong. It should be higher than that because we were putting in more than that. And then this should be 5 volts here. That's good. This should be 3.7. We don't have 3.7. This is our ACN that we were missing before. This should be 0. Then we should have 3.3 on all these, right? We don't have that. We still could have a bad power management chip, but I'm going to start by changing out this MOSFET. Agreed? Concur? Stop jinxing it, chat. I'm going to stop and read the chat real quick too, because I have a hard time because I keep looking down. Have some water, have a break, and let me roll back a little bit. That explains the NCP heating up, probably, because it's getting voltage through the other part. We concur. Good. Okay. You concur. You concur. You concur. Do we have any of these? Do I have one of these boards? Here's my Latitude boards. That looks like the same board, but it has a different circuit here. It's funny how close these boards look, right? So the shape-wise, I was like, okay, that's the same board. Set it down, looks the same, but it's a different size, for one thing. And the circuitry here is different. It's like missing those components. So we'll find another one. That one's wrong. I don't have any of those 6314s, by the way. That's why I'm trying to find a board. Most of the MOSFETs that I keep in stock or in my drawer there, my box, my Soren box, is all going to be Alienware. Alienware? I don't see any. Might just need to find one that has it on there. Look at all that in concurrence. Let's just scan around, see if we can find, it was a 6314, right? I can't remember. 63... 69? What? 60... I scratched it too much. 6354. 6354. $63.54, so that's what we want. So now we just need to find a 6354 that we can steal. Borrow. We don't steal. Borrow. Thank you, 6354s. Mm. 6354, where art thou? Where art thou? trying to think of what would have it on it. Oh no, my camera's about to overheat again. What's the odds of that? It starts blinking at me. That's how I know it's about to die. And I love it. I love it so much. Here, we'll switch it to the thermal mix. There we go. Reoperate. What is that supposed to mean? Reoperate. It's confusing. 6354. 60. Never even heard of a 6354. 63 what? We could do anything, right? 6304 if we wanted, right? Anything that ends in a 4 with a 63 at the starting. 6314s. Those are dual MOSFETs. All right. About to throw all these boards across the room, man. Can't believe I didn't find one of these. All these boards look so similar, but they're so different. Can we use a B04N03? No, we can't. No. Reappropriate. Yeah. What would have it on it? JFix would have the voltage by now. You're killing me here. Where's JFix? He's sleeping right now, right? He's sleeping night-night. There's another stack of boards. I have too many motherboards. There we go. Here we go. All right, so apparently I could just use B04N03s. See that? This is a different board. It's the same board, but it's a different manufacturer. So let me show you what I mean by that. So if we have, this one was made by HSB. That's who assembled this one, and I'm assuming this one was made by GCE. Yep, GCE. Okay. The board number is an LAJ27 something. Okay, 271P, and this one is a 271P, so it's same board print and even the same version, right? Same version, same board print, same everything, but HSB did this one and GCE did this one, and then they stuffed them differently. So we can just use a B04N03 on here, apparently. Now, the question is, I don't think we have to take, we don't have to replace both. I think we're just replacing one, the high side, because this is the high side. And I don't think we need to worry about that, but we can do both at the same time just because it's easier. It's easy. Yeah. Let's do both. I think it's just smarter to do both just because then it's just one less thing for us to have to think about, you know what I mean? Jelly bean. Since we have them. Let's get these guys removed. And you have my beautiful face all over again. Isn't it kind of nice to get a break from looking at my face? My beautiful face. Don't forget to protect the plastics. So here's this plastic we're going to protect. I can put a little bit of protection on it. My plan was to actually, what I end up doing, say this is my hot air station, my miniature prop of a hot air station. I'll heat over here as much as I can. So I'm just like heating, trying to get this whole area hot. And then I'll come over here just for a second to try to pull that off. And that way you're not like sitting here heating here and melting that, right? So you're just trying to heat the board over here as much as you can, and then you come over here for the last second. So I'll probably can come over here, take this one off first, and then that will distribute some heat over. Now we can add a little bit of heat resistive tape here. it's only going to, you know, help a little bit, but we'll just do that. But if anyone's asking, so this is the one that has a short between the gate and drain. This one was fine, but replacing both of them is probably optimal, especially if we do actually have a short there. Now, there's a chance that the short is actually in the power management chip anyway, but we were just going to change these out because it's easier to do both and just do it and move on to the next thing. Go for the magic wire. This one you can't do magic wire because it's actually pulsing it down. So if we put 20 volts right here, we're putting 20 volts everywhere. This machine runs on 8.4 volts, and so we don't want to do that. So we're going to heat over here as much as we can away from this. And I'm blowing the air away too. Yeah, as long as it's 30 volts, but the thing is that it needs to be able to pulse. That's the thing. I want to make sure that, because it's not like it's just an on-off MOSFET. It needs to be able to pulse at the right speed or have the right capacitance in there or response time. So that's why I'm actually surprised that it can use a B03 and 04. So now it's hot, I'm going to add a little bit of flux. Flexity to flux. Need some air. Ooh. Smell it. Okay, that one's off. That one's off. And of course my pad's all swelling here when it gets really hot like that. Lead solder. Yeah, if I add lead solder, it will help. Shoot. I think I'm going to lift this up next time, get it off my desk. Should we check to see if these MOSFETs are bad while we're at it? Let's measure these. Does everyone remember how to do this? To test to see if these are functioning, put it in diode mode. We're going to measure from here to here. We should get a beep. Here we should get nothing. And if we flip these around, there's a beep. And then this should shut it off. And now it's doing nothing. So this is the on-off pin. So if we put positive voltage here, it actually turns it on. If we put negative voltage here, it turns it off. So this one's good. Now, this one could measure good or can measure bad. We'll see. So it's off. Touch here. Nothing. Flip it around. Shorted. And so this one, you have to put positive voltage on that pin. So this is the opposite of the other one, right? Because I think one's a P channel, one's an N channel. No, wait, they're both the same. So why was... one was triggering backwards. Yeah, I think one's bad because it wasn't flipping right when I wanted it flipped. Is it legal to use leaded solder in commercial repair? It was banned. I don't know. This isn't commercial repair. This is just fixing people's laptops. And if they want it fixed with a year warranty, I'm using it. All right, so let me pull these off and we'll move them over. I'm gonna raw dog these off of here. I'm not gonna cover that up. Time to raw dog. For the sake of science, concur. What happened to the 7560 you made a YouTube short a few days ago? Did the customer replace the GPU? Oh, that one. That was so funny. Like, when I opened it up and took the heatsink off, and I was like, what? It's not even touching this thing. Yeah, we just sent it back. The person was like, oh, okay, yeah, we'll just buy we'll get a CPU ourselves, or a GPU, I mean, GPU ourselves. And that was it. They just had to send it back. I was like, okay. The GPUs were expensive on those. These were both the same, right? Yep. Right. Raw dog it. Here we go. Laptop repair raw dog style. Alright. Almost hot enough. Almost hot enough. There we go. That one's good. Almost hot enough. Get in there. Good. Add some fluxity flux. Now I took these off and set them down in the same orientation on the mat. That's how I knew how to just put them right back on without having to check it. And that was my trick. I think, hopefully. Hopefully I did it correctly. Hopefully. So these are probably going to measure shorted because they're hot still. Well, not shorted right now. What about the outputs? It's fine. Oh wait, this is the gate pin. Okay. So that's all measuring fine right now. I'm going to dry it off, or clean it and then we'll dry it off. Did the CPU transplant work? No, just as expected. No, it's funny because it did the exact same thing that the board was doing prior to me changing out the CPU. So I don't know. It's a weird symptom where it kind of pulses on. So we tried a couple of other things. I'm not 100% sure that the CPU we pulled off was fine. I'm not 100, you know, that's the, okay, this is another thing about CPU transplants. Do you have a good CPU to put on there, right? So even like, so me and Black Horse are going to do something. I'm going to send him a board, a bad CPU board. I'm going to send him another board that has a good CPU, but how do I know the CPU is good? You have to have it where the board turns on. Well, if the board turns on, you might as well keep that board. And this is the hard part. And I can tell you that anyone that you're buying like on AliExpress or something, the CPU is like, you know, you're testing it for them. They're not sending you a good one. They're just basically sending you one they pulled off of a board, and then you test it and you tell them if it's good or not. So that's the hard part, and you're wasting time. And then so every time that you just swap the CPU, it gets charged. This is how that works. So measure across here. Measure across there, measure across here, measure across here. So all that's measuring good. Let's measure to ground, make sure we don't have a short to ground. All right. Do you think it's going to work? Think it's going to work? I don't know. I don't know, boo-boo. We will see. Oh. You blame the 2 ripped pins that weren't attached to anything? Yeah, so there was 2 pads that we didn't attach to anything, but yeah. You need 4 MOSFETs to make AC. To generate AC? Is that really? I don't know if I've generated AC before. Okay, you have a Precision 7550 that doesn't post. Can you easily repair it? But from India. So expensive to ship. No, we don't repair anything outside the United States because I cannot warranty it. I do a 1-year warranty, parts and labor warranty on my repairs. I pay for return shipping, all that stuff. And 1 warranty repair for an international repair would cost more than the repair, well, cost more than the profit I get out of a repair, which isn't very much. So I don't do repairs outside the United States except for Canada. Okay, Let's get some Ramo in here. We haven't even cleaned off all the corrosion yet, but the corrosion, it wasn't that bad. Poll? Do we want to do a poll? Or do you want to raw dog this, man? So this is going to be the main power rail. I haven't plugged it in yet. So we get poles going, right? Or not? Will it work? Will it work? Oh, okay. Will the raw dog be raw dogged? I love it. I love it. All right, so 89% so far. I love, man, you guys are optimistic. I'm not even sure that high. Let's see, 87%. There we go. 89 on YouTube and 75 on Twitch. Premise, what'd you vote? Dave, what did you vote? I want to know. Don't know what the poll means, so you voted no. So raw dog, I raw dogged the repair, and then I'm going to raw dog turning it on, basically is what I was saying. So is it going to fix it? It's a yes or no. Raw dog is the method, not the result. Wes said yes, maybe. TikTok said yes. I voted raw dog. Vote for raw dog. Okay. I'm leaning towards yes, just because it seemed like that MOSFET was no good. But I've seen this happen before, where the moment I plug this in, that MOSFET shows shorted again. So that's kind of the thing that throws the wrench in it. So the moment I plug it in, that ends up being shorted again. Okay. All right, here we go. West College Station. Aren't you in College Station? Right? Okay, here we go. I'm going to plug this in. I have the meter on the output of that, so we can see if it's going to go to 8.6. It went to 6.2 for a second, then shut off. And that's it. Plug it back in again. 6.1, shut back off. Let's do the other one. All right, so the main power rail is still doing the same thing. Now, whether we have a power management chip issue, I don't know. Don't know. So that would be my next thing, is to change the power management chip out. But we could also inject 8.4 volts there, maybe. I don't know if that's going to do it. Because we're still doing exactly the same thing. And then we want to measure the gate pin, probably. See what the gate pin's getting. Because we should be getting 20 volts on this side momentarily. 20 volts, and then shuts off, 20 volts, shuts off, 20 volts, shuts off. Interesting. Okay, so the 20 volts aren't staying on. And so it's not a matter of having 20 volts just staying here on this side. Oh, sorry. So we have 20 volts on this side. It's not a matter of having 20 volts staying on this side the whole time, and then this thing pulsing and then not being able to produce it. It's a matter of the 20 volts turning off on this side. So why is the 20 volts turning off on this side is the question. That's interesting. Does that mean, is it time to get our jumper wire out? So what we'll do is we'll take a jumper wire and we'll put it from here all the way over there. Raw dog. Or we'll just jump one of these guys. Let me see what this does when I plug it in. So we have 20 volts constant here. And this one, we're not getting 20 volts constant on the output. But we have 20 volts all the way to here, but we don't have 20 volts on the output. And then what's controlling this gate pin here? We got 18 volts on the gate pin. What the what? That ain't enough. We should have 25 volts, correct? Or is this the one where we need it to be low? That ain't enough. That ain't enough. We may have this. This may be the bad MOSFET, or again, it's the power management chip that controls that MOSFET. What time is it? 9:30. Okay. Yeah, I'm going to have to wrap up soon. Fortunately. I suspect if we jump that MOSFET, the thing will turn on and work. So let's jump it for science. I don't think it's a PWM fail, because I think that if we look at this pulsing, it pulses up to 6.8 or whatever it is, and it shuts off because this thing's turning on momentarily, 20 volts, and it's shutting off. So, so we're just going to make 20 volts be here all the time by jumping this one right here. So I'm going to get all my stuff, ducks in a row here. So we're going to get that here. I'm going to put my, we're going to be measuring this coil while I plug in, let's see, I don't know if I have enough hands here. I'm going to plug in this first. We're going to do sparky spark, I guess. All right, we're going to jump it with some tweezers. That's not working. Oh, man, I can't get in a good angle. Change position. All right, try it again. Doing a lot of jumpy jump stuff here. $1.2 volts. Is this getting energized? So we have 19 volts now to our, we have a constant 19 volts over here now by whatever we just did. And then now we're not getting the output here. I think power management chip's next thing. It's funny, these two boards have similar issues. But we're not going to spend 2 hours, 2.5 hours on this one. We're just going to, we're going to win. We're going to win it. We're going to win it. Ugh. Pull this guy off of here. eBay. I think eBay's working in cahoots here, saying, hey, let's ruin all these things here. Ruin them all the same way. So 9538CH. We have a donor board. To one error in our future. That'd be crazy. They're all three of them are bad CPUs. Now, in general, this type of error, you won't have a 2-1 error, so I don't know. I doubt that will happen, but that would be crazy. 2-1, here we come. 2-1, here we come. Where's my flux at? Where the flux at, yo? There we go. And see how it just kind of sucked itself on there? Look at that. Beautiful. It's like it wants to be there. And it's a happy little place. Okay. Is this going to work? I don't know. I don't know. It's the next best thing. And then after this, then we're going to change out these input MOSFETs right here, because it has to be something in this area. Oh, it's so funny. It's so funny. All right. Let's plug her in. 0.08. That was higher than normal. I'm not powering on though. I'm going a little faster for you guys just to let you know, because we're getting close to wrap up time and I want to be able to get something done. So, okay, we got 19.6 coming here. What I want you to pay attention to, we got 19.6. Here's what I want you to see. 19.6 coming out of this MOSFET. What do we have going into this MOSFET? 20.1. Do you think that's a good thing or a bad thing? The answer is always no. Wait, would that be correct? The answer is it's not a good thing. So what you want, ideally, is if you have whatever's entering this MOSFET should be exiting this MOSFET. So you see how this is 20.1 going into this one, and then coming out it's 20.1. So if you have 20.1 coming into this one, you should have 20.1 coming out of this one, and you have 19.6. Why is that? Well, we're either not getting enough gate voltage, which that does not look like enough gate voltage to me, or we have a problem with this MOSFET that's has a leak or whatever you call it, right? It partially shorted or something. So we're changing that guy out next. Go. Now you get to see me in real speed. This is what I would do whenever I'm working, is I just kind of go to the next thing, like, okay, this thing needs to go next. And if this is what's bad, we've changed out exactly everything we just did on the other one, right? It's pretty funny. All right, and PQ4 is off. Let's grab a donor board. Is this our donor board? Yep. PQ4 is right there. Raw dog style, I'm not even gonna peel that thing back. This is super raw dog. Look at that. Let it go. Look at it. Breathe the fumes. There we go. You like how I did that? Yeah, my kids are going to bed soon. That's why I need to get home. I'm like, all right. Nah, it's a waste of time. This is a waste of time? Or what? You're talking to somebody else, probably. Okay. So now we need to see if our gate voltage looks better, if our output voltage looks better. If everything looks better, then we can start on our third one. No, I'm just kidding. I don't have time for the third one, unfortunately. And I'll have to talk with the customer who was in chat earlier saying that his 9520 was in there, and see if he wants to hold off for another live stream, or if he wants to just have me fix it like normal. All right, let's plug it in again and measure the output. Okay, so here's our output. I'm going to plug it in. 3, 2, 1. Did you see that for a second? I'm going to unplug it again. We got 20.1 for a second. but we still have that drop there, and we're still getting 18.9 here. I want to figure out what we're supposed to be getting there. I feel like we should be getting 25 or something. So I'm going to let that drain down on the gate pin I'm measuring. Plug it back in. No, 18. Why are we not getting 25 there? Should we be getting, is this a high or low? Is this an N or P? I have no idea. I feel like if it's at 18, what is that? Can you read that? It's MPN gate is lower. So the gate should be low. It should be like a 10 volts in order to get the full thing out, right? I don't know if I have a board view for this. Ultrasonic cleaner, yeah. 18, that's worse. You failed another computer. Well, I think it's actually the same value. It was at 18 before we started this. I haven't done anything is what that means. I've literally done nothing but change stuff out and did nothing. And I have no idea where that pen goes to. Oh, there's a pair of them. There's more on the back. Do these work together as a team? What do you think? What do you think? I'll measure these over here too. Oh, these have nothing on them. 0.12. So we have 19 coming in here, 0.6 here. So what creates that gate voltage? Did we figure out, yeah, it's resistors or caps or something, pour some whiskey on it. Oh man, not made worse. No, it didn't get made worse. It's the same as it was. Yeah, I don't know. It needs to be cleaned. It needs to be, it's like, you know, the corrosion like right there. What if we just clean this corrosion right here and it's like brand new? You're like, okay, that's all we needed right there. Corrosion fixed. And now the board turns on. 19.6, 18.8. Spec sheet says low enable. Yeah, so this usually whenever it goes low on here, you put it at like 10 volts is what you do for this. Well, that's what I've seen at least on these boards. Let's plug in the battery now that we have all this stuff changed out. See if we do anything different. Battery's plugged in. It's funny because it pulls that current just for a second when you plug it in. Enable low could be 5 or 10. Yeah, I mean, most of the time on Dells, I usually see it at like 10 volts. That's why I was saying that, but it can be either one, I'm sure. Oh, I don't know. Got 19.6, which is stupidly the wrong number. Buy refurbished from Parts People. Yes, you can buy refurbished stuff from us and support me in my work that I'm doing here. I want to run just a jumper wire across here. I really want to know where this goes. We don't have a board view for this, or I haven't looked. And we can see it goes to a via right here. And I'm assuming it's on a resistor. I mean, we could pull it low, I guess, right? Can we pull it low, or would that mess something up? I'm assuming there's a resistor on there. Because I could just do some tweezer action to ground. Tweezer action to ground. That's positive. So this would be ground right here. That would be ground there. Find some nice, beautiful, wide mouth tweezers. So if I did this, that might be crazy. That might be crazy, man. It's not working. I don't know. I'm gonna have to call it for right now. It's getting late. And I usually for the last 10 or 15, 20 minutes, 30 minutes, whatever it is, we chat for a little bit, and I like to at least have a little bit of time to do that. And I'll have to think about this one anyway, because this one's a little different. It's a little bit different. It could be the power button itself. Well, here's the thing. Here, I'm going to plug in the battery again. We have the battery here. All right. And here's the power button. Watch this. Wait. There it goes. Turns on. But it's not turning on the CPU. It's only turning on this one little chip here. So. Nothing got fixed. We worked on 2 machines. And the first one, we fixed it so it turns on, and then it turned on to go to a 2-1 error, which is the bad CPU. And then the second one, similar issues with it. We've changed out all the power input stuff. There's some signs of liquid damage, so we might have just a resistor somewhere that's blown out. We don't have any shorts on the board, so it's not like we can just find a short and change that out. So it's kind of like a whole kind of, I don't know, rundown. These boards aren't very expensive. That's the thing about these motherboards is, I don't know how much they are, but they're probably less than my board repair. But so I normally probably wouldn't even fix this, but because they requested it, I would do it. Otherwise, we would just offer the board replacement. So we can go through some of these questions here. Jesus, if you're asking when the streams are, I do a 6 p.m. Central Time and 9 p.m. on Wednesdays, 6 p.m. Central on Wednesdays, and 9 a.m. on Sunday morning Central Time. Look for the cigar cutter. Let's do that. So in here, it is coming out of here. Yes. Got my cigar cutter too. It matches. It's a Gentleman Jack. So Montgomery sent me some early Christmas presents. So I got some Gentleman Jack cigars and a new water bottle, an alien head water bottle, and some coffee. So I much appreciate that. I'm going to fire one of these up later tonight. For sure. So thank you so much. I appreciate that. Yeah, I'm getting close to calling it. I like to kind of chat for a few minutes just to allow me to read the chat as much as possible, because I'm really bad at reading it during the actual repair itself. Were they from the same seller? No, these are 3 separate people who sent in laptops and said, I bought it on eBay. So I just happened to kind of collect them all together and put them in the same thing. So totally different people. It was just, and I have another one coming in from Facebook Marketplace too. Same type of idea. So, yeah, thanks, Wes. Have a good night. Thanks for hanging out. Maybe you'll come down and meet me sometime. Have a bourbon and call it a day. That's right. I will go have some of my bourbon and tuck my kids into bed. You have a guitar. Wait, Wes, you got a cigar and a bourbon. Appreciate the videos. Thank you. Nearly 4 a.m. I cannot believe you stayed up for 4 a.m. for me. That's impressive. You said you will show us something. Thank you. All right. Let's see, 2 things, or maybe it's just 1 thing. I can't remember. I know I can at least show you this. All right, you ready? Is it real or is it fake? All right, this one's cracking me up. All right, so that's why. So if you haven't seen this segment before, this is the is it real or is it fake segment of batteries and AC adapters. Now this one came in today and it cracked me up, and I'll show you why. So here's our charger. This is a 65 watt charger, 4.5 millimeter tip, okay? So is it real or is it fake? Now, I'm sure you can see, I'm sure you can make a guess right this second whether it's fake or not, right? We have a serial number here. We have a genuine serial number. We have all the, codes. We have all the different things that basically say that it is a, safely made device. But you can obviously see that it says ostrich here, right? Or ostrich as the brand. So, yeah, that automatically says it's fake. But here's where it gets even crazier, okay? This cord doesn't look legit either. The plastic on here is a little weird. The light's a little weird here. But that's not what I'm looking at. What I want you to look at here is the part number. Okay, so this serial number here. So this part number, I made notes for this because the part number here, the 928G4 part number, is actually for a 65 watt, which is this, with the 7.4 inch tip. Not even the 4.5. So this part number here is wrong for the actual tip size. Then, if you scan this, a totally different barcode is in there, a totally different serial number for a YY20N, which is a 90 watt charger with a 7.4 millimeters, thank you, millimeter tip. So these are 4.5 millimeter tips. So this charger is a 65 watt with a 4.5 millimeter, and the barcode says it's a 90 watt with the 7.4 millimeter, and then the number says it's this other one. And then, if you look at the barcode itself, remember the date codes, it's telling you the year is G. So that would be like, it's only supposed to be 1 through 9. So anyway, I thought that this was pretty funny because if you're going to fake something, fake it. Right? Right? Just like, it's not like replaceable tip. You can't change any of this stuff. Like, why don't you put the real part number here that matches this device? And why is this barcode always the wrong barcode? So, anyway, it's super light too. But that was it. That was all I was going to show you. I thought it was pretty funny. I was cracking up. on that. There might be one other thing I was going to show you, but I can't remember right this second. Yeah, I'll have to save it for another time. So on Sunday, we'll work on that other machine, or I'll talk to the customer, see if he wants to hang out until then, and we'll see if we can try to reflow the CPU on that AMD on that first repair that we, was giving the 2-1 error. Maybe we can reflow it and we'll fix it. G equals 7. G could equal 7. Does it actually put out? Yes, it actually works. It's just, I would never want to plug one of those types of devices in because you have really dirty power, because the regulator or the actual switching power supply on there is made with really bad equipment. Just put it into random. The guy at the factory was having a bourbon. Not saying Dell, it means enough with customs. I know, that's why they put these little stickers over the Dell label. Whenever they put Dell on there, they put this AC adapter sticker just to cover up Dell, so it doesn't mess up this stuff. Ostrich is a great humor. Does it provide 65 watts? I don't know, because each barcode was saying it was 90 watts. It's the size of a 65 watt. I wonder if we could try to stress it and see if it would actually put out the right wattage. I don't know. That's insane. So, any last questions before we sign off? Copy of brake calipers were horrendous copies. Thank you, Nathan, in the chat. You're awesome. Thank you, TikTok. TikTok00. I've seen a reflow on CPU on a stream, maybe Northridge fixed. Okay, and did it work? I've never seen it work. I mean, I don't know, but I've never. I mean, with a 2-1 error showing. So, how many hours of sleep am I going to get tonight? Probably 5.5 hours. It's probably what's going to end up happening. I'll have to get up pretty early every morning. What laptop do you recommend? It depends what you want. If you want gaming, then you're going to want something that has ample cooling, and then I would not get like the highest end graphics, the highest end of all that stuff. Would get kind of the middle of the road, like a 4070, 5070. If you're going to get like a graphics chip, if you want just a regular laptop, just get like a dependable one. You get a Latitude. If you want something that's a little more sleek, you can get an XPS. But again, don't get the highest end. Don't get i9s. Don't get 9 Ultra 9s, anything like that. Get the 7s. Reflowing chips can help either significant thermal loads or impact. I mean, if there is some solder cracks or whatever in there, the fact that all these MOSFETs blew out on that machine, to me, I mean, I don't know. It could mean there's a short somewhere in there. It looks like we've tried the reflow AMDs already. I haven't tried it, but I've heard people say that they've done it. Well, you take a Lenovo Tiny PC to add a second MD. I don't work on anything but Dell and Alienware, and I generally don't work on things that already work. I definitely don't modify things. So if it's working, I don't want to break it. So reflow CPU that is intermittent. Yeah, I've done that before, but not one that's giving a 2-1 error. And you've tried to reflow a GPU and not a CPU. And I've reflowed a CPU or a GPU that wasn't showing up all the time, and that's fixed that. So, may have ever thought a YouTube stream would be this popular? Never in my millions of years, never. The first video I put out that was the repair video, the new laptop repair. The first time I put one of those out, I'd already been doing shorts for about a year. But I put one of those out thinking that I would get like, 1,000 views or 2,000 views. I got 30,000 views like overnight. And then the next video I put out got 250,000 views. And I was like, what the? Like, I thought it was like shorts were the ones that were supposed to get all the views. So I actually get more views on these long forms than I do on my shorts in general. The shorts are a different animal. You have to kind of you really have to craft them a certain way, and then they do really well. I mean, I have some that have millions of views, but most of them don't do that well. So, does Dell do only Intel? No, because the machine we just worked on, it was an AMD, not this one, but the one prior to this was an AMD. So they have some Ryzen edition machines, and I hate them. Metal bucket of sand. I do need a metal bucket of sand nearby, and safety goggles. I need all this stuff. I just don't have any of that stuff right here. You're looking at the Area 5118. That's fully loaded. Again, I would not get top on all that stuff. So that's just my opinion. I mean, I can't vouch for that machine because I haven't worked on it. But if I was buying one, I would not buy the 5080 or the 5090. I would buy a 5070, and I would get like the Ultra 7 or something. Solve them, Probler. 9520 would probably be easy pizza. That would have been nice. Yeah, so if you wanted me to hold off for the next stream, we can do that, Luca. I don't know what you want to do on that, but we can talk tomorrow, and I'll figure out what you want to do. Going to buy a larger preheater. I don't know. I am looking. I may pull the trigger on an IR 6500, which is the BGA machine, because they're pretty cheap and it has a bigger preheater already. So that's the thing. It's like my preheater is a 400 watt and it's only like 100 millimeters by 100 millimeters, and the other one is a 800 watt. And or the IR 6500, 800 watts and 180 millimeters. So that's already bigger. So I may just get one of those. It's sharing this thought. Finding fault mythology is so interesting for me. Well, thank you. That's kind of my whole idea, is getting in my brain. Okay, I can't answer any more questions right now because I got to get, yeah, it's already 10 p.m. My kids are getting in bed. I got to go. But, well, I want to thank every single person who showed up tonight and donated to the stream. Any of the donations going to the stream are going to the repairs that I worked on, and hopefully that will help them, you know, get the stuff fixed up. I want to thank my moderators, and these guys are working so hard, and I appreciate them. And I appreciate each and every single one of you guys. Montgomery, thank you for the early Christmas present, and I'll see you guys Sunday. Have a good evening.